All right, my lions, welcome to yet another power packed session, and today we are going to start with limits. And if I talk about JEE Main, the weightage is not that high, but if I talk about limits, continuity and differentiability combined chapter, then it is considered as one of the high weighted chapters, right? So if you do not understand limits, then continuity and differentiability you won't be able to understand, right? So limits is a very important for your continuity and differentiability. I to always say that to understand continuity, na, if you understand limits, then half of your job is done, half of your chapter continuity is done. Okay, all right, so make sure that you attend the session till the very end, and also let me know in the chat box whether I am perfectly audible and visible. All right, I can see Surya, I can see Mohammed, I can see Leslie. Okay, all right, welcome to the session. And also we are going to talk about the importance of the chapter, nature of the chapter, high weightage topics of the chapters and everything, right? But before that, I have a small story to tell you all about limits. Okay, and yes, one student is asking graph, sound not clear kya? Sound less, sound not clear. Good evening, Gunjan. Good evening. Good evening. Sound clear or not? Okay, voice is down. One student is saying voice is so down. Voice is down. Voice is down. Let me check ek bari. Good evening. Sound clear or not? Okay, voice is down. One student is... No, I think sound is fine. Sound is fine. Mohammed, sound is fine. No. Why are you saying sound is not fine? Now, two videos I have already promised you about two videos. First is transformation of graphs, and the second one is determinant. So, those two videos I'm gonna record tomorrow. So, most probably it will get uploaded by Friday. Okay. So, sorry about that. I got late in recording that video. Okay, all right, now let's talk. Voice is very low, is it? No, voice is not low. You increase the volume because I can see on my phone. Okay, now let's start with the limits right away. But before that, let me just give you an example that what is limit. Okay, so the story is all about what is limits. Okay, integration, yes, definitely we are going to cover everything. Duration of this session, the duration I already told you, 4 to 4.5 hours. So it will go up to like 10, like 10ish. Okay, all right. Okay, just tell me one thing. What is your favorite crime drama or crime show? What is, which one is your favorite crime show? Because mine is Crime Patrol. I'm not sure about South. Which crime drama is popular in South? Which crime drama is popular in South? CID, Gunjan is saying CID. Acha, nice. CID was also good, but it was like it doesn't air these days, right? Old CID, yes. Daya. Okay. Anyone else? Anyone else? Anyone else? So Crime Patrol is my favorite. Okay, Madhav is also saying Crime Patrol, CID, Lucifer. Acha, Lucifer is also one of the thing. I'm not sure. I can't read Tamil. I guess this is Tamil or Telugu. Tamil mein there is written something. What is written over here? Can you please tell me? What is written over here? So I have a story to tell. Okay. So in Crime Patrol, there was one of the episodes which I made it up. Okay, I have a script ready for Crime Patrol. So what happened is, one fine day, one guy was missing. Yes. So one guy was missing, and his friends tried to call him, and his phone was not reachable. And then they realized that, okay, we are not able to find him anywhere. So they went to police. Okay. So he used to stay in this particular building. He used to stay here and this building, and his friends call him, and they realize that phone is switched off and he is not currently in his apartment. Okay, So what did they do? They called police. Okay, so yes, they called police. So they realized that we need to like lodge an FIR and missing complaint, we have to file a missing complaint. And you know what happens? Whenever something happens, police always come late. Okay, police always come after the crime has happened. They never like come before crime or like while crime is happening, because their job is to patrol everything, to control everything crime related things. Okay, so they actually called police, and they told the police that we are not able to find our friend, please help us find him. So what did police do usually? So they start asking, acha, where was he last time? When did you see? Last time when did you have a call with each other? Last time, so when did you spot? So they just tried, and they just realized that call recordings also we can just do, right? So one of his friends told that I had a chat phone call with him at 9 o'clock in the morning. I had a phone call at 9 o'clock in the morning. Okay, so 9 o'clock they actually figured out where is the exact location at 9 o'clock. 9 o'clock his phone was active. So police tried to find the exact location at 9 o'clock. It was around his society only. Yes, so it was around his society. So they tracked his phone, and they realized around 9 o'clock he was surrounding his society. So police went outside their society, their apartment, and they realized that okay, so they always ask this, na, chai wala, they always inquire surroundings. So they started inquiring this tea stall, that have you seen this guy is missing, what happened to him? So basically this chai wala told yes, he was here around, so he was here around 9:12. So the guy was drinking tea around 9:12, and after that his phone is not active, he is also not active. Okay, and then after that they started searching that what exactly happened before 9:15. Okay, so they started telling what exactly happened before 9:15. Now let me tell you. So what happened is the guy got missing at 9:15 a.m. Okay, at this moment he got missing. So usually what does crime patrol and police people do? Tell me. So they just go little before that. They start thinking, okay, if 9:15 was a problematic area, that 9:15 was problematic time, then what we can do is we can check out that what exactly happened at 9:14. If they are able to figure out what happened at 9:14, then it will be easier for them to figure out that what exactly happened and where is currently he is residing, right? So always the missing time, so right before missing time they always check, because this time they actually do not know that what happened exactly at 9:15. So they always think about 9:14. If they have some information or some hint what is happening around this time 9:14 a.m., then it would be easier for them to track. Yes or no? Yes? Clear? Yes, so the story is clear. This is what happens in limit. Now let me tell you the same thing is happening in limit. Okay, so just tell me one thing. Same thing is happening in limit. So I will give you a function. Function is y is equals to x square minus 4 upon x minus 2. Now I am absolutely behind what happens at x equals to 2. Anybody can tell me what happens at x equals to 2 in this function? Can anybody tell me what happens at x equal to 2 in this function? So many students are writing. Okay, they will drink cup of tea in that shop, ma'am. Yes, Dharani, absolutely. है ना? Now, chalo, tell me. At x equals to 2, what is happening? The guy is missing. He's been kidnapped. Yes, the moment you put 2 over here, what do you get? At x equals to 2, you are going to get 2 square minus 4 upon 2 minus 2. That is going to be 0 by 0. Oh my God. That means x equal to 2 is the corrupted area, I would say. Okay, x equals to 2 is that area which we are not able to understand. Now to understand overall function behavior at x equals to 2, what we will do is we will not talk about x equals to 2 because this is the problematic point. So we will talk about x equals to 2.000001 and we will talk about x equals to 1.99999. Are you getting my point? Okay, another way of writing this is x equals to 2 plus h and x equals to 2 minus h. Here h is a positive small quantity. So 2 plus h is 2.001 only and 2 minus h is 1.99 only. Also another way of writing this is x equals to 2 plus and x equals to 2 minus. Okay, so 2 plus means slightly greater than 2 and 2 minus is slightly less than 2. Okay, alright, so here 2 though we cannot put, but can we put 2.0001? Can we do that? Okay, so y will be equals to, now if I just factorize it, x plus 2, x minus 2 upon x minus 2. Let us put 2 point something, okay. So y will be equals to what? 2.0001 plus 2, correct? And this is 2.0001 minus 2 upon 2.00001 minus 2, correct? Okay, so what is this? 2.001 minus 2, so this is 0.0001 upon 0.0001, right? These two quantities are same, we can cancel these two quantities, they are equal actually, and y will be equals to 2 plus 2, 4.0001. So the moment I put x equals to 0, I am actually getting 0 by 0, which is not defined in mathematics, right? Okay, and the moment I put 2 point something, did you realize I am not even getting 0, I am not getting not defined, I am not getting anything, but I am getting a finite number. Y is equals to 4 point, very small quantity, so y is approximately 4. Can you see y is approximately 4? Okay, alright, so now you know that what is the need of a limit. Do you understand what is the need of a limit? It is exactly same as, because 9:15 pe if a person goes missing, so you just can't sit ki 9:15 pe what happened, I don't know. I don't know what happened at 9:15. I don't know what happened at 9:15. You will obviously talk about, okay, if 9:15 I am not able to figure out, 9:14 pe what happened, 9:13 pe, 9:12 pe. So you will go just before or just after that, right? So same thing is happening over here. So this is what your limits is. Okay, all right. So a number can be approached. Now please understand, a number can be approached from 3 sides. Yes, a number can be approached from 3 sides. So the very first side is x equals to 2. Okay, so I will say what is the value of the function at x equals to 2? That too we all know, right? And the other is from right hand side also you can approach the function. What does that mean? That what happens when you put slightly greater than 2, that is approaching the function from right hand side, and approaching the function from left hand side is value slightly less than 2. Okay, so a function can be approached from 3 sides. Okay, clear? Now what is a limit? Let us define a limit. Okay, what is a limit? So limit definition says that okay, so value of function limit of x tend to a plus is equals to limit f of x tend to a minus is equals to L, and that is a finite value. Let us understand that this is the definition final. Now this is the final definition. Understand that limit of a function exists when you approach that function from right hand side, and if you approach the function from left hand side, and if both the values becomes equal, this is your right hand limit at x equals to a. This is left hand limit. You are approaching the function from left hand side. If approaching the function from right and left side both becomes equal, then we will say, and it should be finite also, then we will call that yes ma'am, function exists. Okay, sorry, limit exists. Okay, now I will give you some cases, okay, graphical cases, and you have to tell me in this particular case limit exists or not. Are we ready? Are we ready for it? Yes? Are we ready for it? Yes, tell me. So just look at this graph, and if I ask you, this is your graph, and you know that the value of function at x equals to a is L. Okay, now my simple question is, what do you think? Limit of this function exists or not at x equals to a? Yes or no? Limit of this function at x equals to a exists or not? Yes or no? Okay, so Vijay, Anand, yes. Dharani, what happened? Extreme, yes. Dharani, okay, just tell me, exists or not? Yes, yes. So how will we check? So we will talk about x. So this is x equals to a, this is x equals to a plus. So we will take a value which is slightly greater than a, right? And we will check what is the value of this function, of this graph at x equals to a plus h. So the value is approximately, so this is your L, right? So the value is approximately very near to L. So limiting value is L only. Okay, we are neglecting this delta, because obviously if you put a, you get exact L. If you put slightly greater than a, then you will get L plus some small quantity. And if you put a number which is less than a, slightly less than a, okay, so again can you see, you are going to get L, a slight lesser than L, so we will consider it as L. So here your left hand limit in this case is also L, right hand limit is also L, right? Now the value of function at x equals to a is also L, although I am not interested in that. It is not contributing in limit. I am just worried about my left hand and right hand limit. Okay, this time function ka value is also L. So yes, limit exists in this particular case. Okay, all right. Chalo, now let us see how many of you tell me the correct thing. Limit at x equals to a exists or not? Yes or no? Limit at x equals to a exists or not? Okay. So Surya is saying downloaded all your lectures. Kya baat hai? Very nice. Okay. Limit exists or not? Pranav is saying no. Acha. So let us check. Let us check. Limit exists or not? Pranav is saying no. What about others? Yes, Gunjan. Limit exists or not? Okay. Okay. Paruthi is saying no, Dharani is saying no, Gunjan is saying yes, study with me saying yes. Okay, a lot of yes, a lot of no, mixed reaction, okay, yes and no combination. Infant is saying, Akhil is saying yes. Okay, all right. Somebody is mixing continuity also, but I will not talk about continuity. We will talk about it in next lecture. Okay, chalo. Now tell me, limit of this function x tend to a plus, right hand limit, we are talking about right hand limit. Okay, so this is your a, and right hand limit will be just after a. Tell me, just after a what is going to happen? So just after a, if I read the graph, I will get the value of right hand limit clearly is L1. This is your RHL, which is coming out as L1. Okay, now left hand limit of x tend to a minus left hand limit, so we will go slightly less than a. Okay, so slightly less than a, and can you see again I am at L1 only, so this is also L1. LHL and RHL becomes equal. What does that mean? Limit exists and is equal to which value? And equal to L1, my dear students. What does that mean? What is actually the difference between first graph and second graph? So here the value of function at x equals to a is L2, right? Only the value f of a, if I talk about f of a, you will tell me L2, but I am not interested in that. I am only interested in that what is happening on the right hand side, what is happening on the left hand side. Okay, all right. Yes, now tell me this. This is, so we have already done now. So left hand side say I am approaching L1, right hand side say I am approaching L1, sorted. Okay, now who is going to tell me about this? Yes, limit exists or not? Limit exists or not? Limit exists or not? So again we will do the same approach. Okay, so if I, so right hand limit, and here I am only talking about x equals to a. Okay, so right hand limit, that means limit of function x tend to a plus. Okay, so a plus, you will go a little right of a and then you will check what is the value. So value is clearly near L2. So right hand limit is L2. What is your left hand limit? So limit of f of x, x tend to a minus, now you will go slightly less than a, right? Slightly less than a, and your graph says that it is at L1. So this is your L1. So can you see both are not equal? So does not exist. Does not exist, my dear students. Clear? Okay, so graphically I hope that you are actually able to understand. है ना? Now any graph will come, like any graph will appear, you will be like, yes ma'am, we know where limit exists, where limit does not exist. Okay, so now let us just talk about without graphical approach. Okay, so what about this? Limit exists or not? Tell me, and if it exists, then what is the value? So if I talk about the left hand limit LHL, so what I'm gonna do is, I'm going to put 1 minus something. So x will be equals to 1 minus h. So 1 minus h plus 2, that will give you 3 minus h, approximately it will be 3. So limit, if limit is written, you don't have to write the approximate, because limit value is 3. They understand that limiting value, it is already there. What about RHL? So ma'am, 1 plus h plus 2. So this is 3 plus h, 3. Both LHL, RHL are same, so we are going to get 3. Okay, all right, what about this? Okay, so 2. So again, LHL, 2 minus h square minus 3, 2 minus h. Okay, and this is 2 plus h ka whole square minus 3, 2 plus h. Calculate. If you calculate this, it will be what? It will be exactly same as the way you put 2. So 2 ka square 4. Okay, 2 ka square 4, 4 minus 3 2 is 6. So minus 2, yes, and this is also minus 2. RHL and LHL both are minus 2. Yes, hai na? So now you understand that where exactly you have to plug in the value and where exactly you have to doubt. Okay, now quickly we will answer everything. Okay, now every time you don't have to calculate LHL and RHL, because it could be intuitive also. Yeah, these two values should be same only, right? So 0. Now the moment you put 0 plus or 0 minus, this will give you log of 2. The moment you put pi by 2 plus or pi by 2 minus, both values will give you what? Sine of 2 pi by 2 plus or sine of 2 pi by 2 minus. Sine pi plus or sine pi minus will give you a 0. Okay, and this is limit of sine inverse x. So sine inverse half. Sine inverse half is what? Again, sine inverse 1 by 2 plus or sine inverse 1 by 2 minus will give you same value approximately. So this is going to give you pi by 6, 30 degree, right? Okay, and what about this? The moment you put x tend to 2, this is not x equal to 2, this is tending to 2. So 2 ka square. So this is going to give you 4. Yes, clear? All right. No, we are combining the chapters. We are studying the whole limits as far as your JEE is concerned. Okay. All right, yes. Now limit. So basics we are going to cover, and then we are going to move towards all the JEE Main and advanced level. Okay. Chalo, tell me about this. Now who is going to tell me about this? Now this GIF and fractional part can make a little trouble in your home. Okay. All right. So now we have to calculate LHL and RHL. Okay. So how will we do that? Shall we do it with the help of the graph? Yes. Okay. So actually it is not that difficult. Just tell me that if I put left hand limit means I am putting a number which is slightly less than 2. What is that? 1.99999. So 1.99999 and so many nines I can't even count. है ना? So fractional part of this is what? We are only looking for fractional part. So fractional part of this is 0.999999, which is approximately 1. Okay, okay. ठीक है. All right, and RHL में what we will do is we are going to put 2 point something. So 2.000000001. Correct? What is the fractional part of this quantity? Tell me. Fractional part, that means after decimal. So that will be 0.00000. So this is actually tending towards 1 and this is tending towards 0. So we will call it off as does not exist. Clear? Does not exist. And if you look at the graph also, no, then also graphically also we can do. Now just be comfortable with graph. Okay? Alright. So can you see 2? So at x equals to 2. At x equals to 2, we can clearly see that fractional part is 0. If I go just after 2, the fractional part is still 0. Can you see the fractional part is still 0 right towards the right of 2? But if I go towards the left of 2, so the graph is this. So the branch is this. And this is your 1. So it is approximately closer to 1. So again, can you see that approaching from right hand side giving me 0. Approaching from left hand side is giving me 0.999. Okay. Alright, now who is going to tell me this? Left hand limit and right hand limit, both you need to tell, okay? So left hand limit, to calculate left hand limit, we are going to put what? One slightly number which is slightly lesser than 1. So 0.9999999. Greatest integer function which is lying between, greatest integer function of a number which is lying between 0 and 1 will give you direct 0. Understand or not? Darshan is saying how does not exist. Does not exist. Why? Because both the values are absolutely not equal. This value is closer to 1 and this value is closer to 0. When LHL and RHL becomes unequal, limit does not exist. Okay. So here LHL becomes 0. Can you see? Greatest integer function of 0.999 becomes 0. What about RHL? Who is going to tell me? So this is going to become 1.00. So I am putting a number which will be slightly greater than 1. So this is actually going to become 1. Okay, this is going to become 1. You know how does greatest integer function works? Yes or no? Okay, so this is also does not exist. Okay, so graphically also if you want to check at x equals to 1, no? So this is your graph. So can you see at x equals to 1 the value is 1. At x equals to 0.9 the value is 0 and x equals to 1.1 the value is 1. Can you see the difference? Right hand limit is tending towards 1. Left hand limit is 0. Okay. Alright. Yes. Now infinite limit. What is the concept of infinite limit? Okay. So infinite limit says that, so we know the definition, right? So LHL and RHL both should be equal, but at the same time both should be finite value also. then only limit will exist, otherwise no. ठीक है. So limit x tend to pi cot x. Do you know what is the graph of cot x look like? So cot x look like this. This is the graph of cot x. Okay, pi pe you will see asymptotes. Now, and this. Now, if you want mod cot x, we are looking for mod cot x. So the graph will be like this. How to draw mod wala graph? Like this. So you have to shift everything above the x-axis. So pi is this value. Can you see pi pe to we are getting not defined. The moment I go pi plus, I am getting infinite value. Pi minus pe bhi I am getting infinite value. Cot pi is not defined. Okay, so cot pi plus pe bhi, because modulus is there now. So LHL is also infinite, but RHL is also infinite. But in this case, limit does not exist because LHL RHL should be equal and it should be finite also. Okay, all right, clear? Tamil students, Erukingla, क्या बोल रहे हो? Yoga with Bhargavi. I am not able to understand your language. Teach me also. Okay, now who is going to tell me? Limit x tend to 0. Okay, so one way of doing it is RHL and LHL. So 1 upon 0 plus h and 1 upon 0 minus h. Okay, so this h is a positive quantity. So this is actually 1 upon 0.000 and this is 1 upon minus 0.000. So this is your plus infinity, this is your minus infinity, and limit obviously does not exist. Okay, all right. Yes, now graphically also we can see y equals to 1 by x graph. How does this graph look like? So this is a rectangular hyperbola. We will study this in conic section. So this is how the graph of 1 by x look like. So at 0, the obviously graph is not defined, 0 we cannot put, but the moment I go after 0, it is plus infinity. So the moment I put 0 point something, it is plus infinity, and the moment I put 0 minus, left towards the left of 0, it is minus infinity. So that's why right hand limit is plus and left hand limit is minus infinity, but because infinity is there, limit does not exist. Okay, all right. Okay, so here these were the basics of limits. Now let us understand, because now we know that like sometimes limit exists, sometimes it does not exist. So why don't we do one thing? We just do some standard thing. Okay, let us identify standard indeterminate forms. Yes, so we have in mathematics 7 indeterminate forms. What are these forms? So this is actually indeterminate forms is not infinity. Understand, indeterminate form is not defined, it is not infinity, it is not minus infinity. Indeterminate word is very different word from other words, and we will understand why there is a difference. So we have 7 indeterminate form over here, you can see. So the very first form is 0 by 0 form, and we are going to spend most of our time in this form. This is very important form. The second most important form is again infinity by infinity. Okay, second important form. The third important form is 1 raised to power infinity. This is also an indeterminate form. Okay, and the rest of the forms now, that we will spend very little time, because why? Because these forms, all these forms you are seeing on the screen, including this also, rest forms you can see on your screen, are actually convertible to 0 by 0 form. Are you understanding my point? So if we spend a lot of our time in 0 by 0, then if we know that how to convert all these forms back to 0 by 0, so after converting we are able to solve 0 by 0, right? So master 0 by 0 and infinity by infinity form. That is what ninja tip of this day is. This is not 11th lecture, this is not 12th lecture, this is a complete limits 11th plus 12th you can say, or JEE Main perspective say, they have, in JEE Main they have not divided 11th and 12th, right? So this is one complete chapter, complete limits we are doing, okay? All right. Now, ma'am, but what is the difference between indeterminate and infinity? Because you are saying 7 forms are there. Why infinity raised to power infinity is not written over here? Why exactly these 7 forms are called as indeterminate forms? So please understand. Okay, one student asking also, why 1 power infinity is indeterminate? So please understand, we will talk about every form one by one. 0 by 0. So 0 by 0, tell me. So if numerator becomes 0 and denominators become finite, so what do we say? That this number is actually equal to 0? Yes. But if numerator becomes 1 or finite number and denominator becomes 0, so this will become what? It will be a very big value. Infinity. Infinity is actually very big value. Minus infinity is extremely small value. Okay. Can you see 0 by 0 form is actually a confused form. Numerator wants this to become 0. Denominator wants this to become infinity. That's why indeterminate, we are not able to determine. Indeterminate. So that's why infinity knows. Infinity is not defined, right? But infinity is not confused. Infinity is not indeterminate. Infinity means I am the highest value. But if you go and ask 0 by 0, you will be like 0 by 0 is confused. Is it 0? Is it tending towards 0? Is it tending towards infinity? Nobody is able to tell. Okay. So that's why these 7 are confused forms or confused people on the earth. And there is no 8th form which is confused. Just ask me, I will tell you. Okay. Alright, now one student was asking, now one more form, similarly I will be taking 1 raised to power infinity. Okay. Now please understand, this is not exact one. This 1 raised to power infinity is not the exact one. This is tending towards 1 raised to power infinity. Because exact 1 raised to power infinity is what? Tell me. If I tell you that you have 2 crore years, you have calculator and you have 1 multiply, 1 multiply, 1 multiply, 1 multiply, 1 multiply in calculator. You do it infinite life. You do it till eternity. In calculator you will get 1 only, no? Right? It is 1. So exact 1 raised to power infinity is what? Is 1 only. But this 1 raised to power infinity is what? Tending to 1 raised to power infinity. What does that mean? That means 0.99999 raised to power infinity or 1.000001 raised to power infinity. Now again, fraction raised to power infinity. You do it in calculator right away. You have smartphone. So open the calculator and just multiply a fraction into itself. 0.9 into 0.9, do it. And keep on doing, you will realize that the number is getting reduced. 0.9 into 0.9 is what? 0.8. Then 0.9 into 0.9 into 0.9 what? Again the number will gradually get reduced. So 0.9 raised to power infinity, this is becoming 0. So this is becoming 0 and this is becoming greater than 1. This is actually becoming infinity. Again conflict arises. Can you see? Again conflict arises. That's why 1 raised to power infinity is indeterminate, confused. Okay. All right. Okay. Clear? Now somebody can ask me that, okay ma'am, why infinity multiply infinity is not indeterminate? Because it is not confused. Infinity multiply infinity is infinity, which is a known value at least. I mean known at least, it is not confused. At least he is aware that I am the biggest value. Okay, again infinity plus infinity will be going towards single value infinity. है ना? And there are some more forms. A upon infinity is 0. If A is finite, infinity upon tending towards 0. Now infinity by 0. Why infinity by 0 is not at all an indeterminate form? Because infinity, the numerator wants this to become infinity, And if the denominator becomes 0, what happens? Again, it tend towards infinity. So both are sorted. Both are actually going in same direction, that is infinity. Both are not conflicting each other. Okay. Now exact 0 raised to power tending towards 0. So tending towards 0, whenever you see in the denominator, na, that means you are going to get infinity. So exact 0 by 0, that means exact 0 by 0.1 basically. Exact 0 by 0.1, tell me. 0, right? Okay. Alright. Tending towards 0, multiply, tending towards 0 power infinity. 0. Open the calculator. 0.1 multiply 0.1 multiply 0.1, tending towards 0. Right? Infinity raised to power infinity will go towards infinity. Exact 0 raised to power tending towards 0 is also not at all like indeterminate form, and this also exact 0 upon 0 minus, again not defined. So these are not indeterminate form because these are not confused form. Okay. Infinity subtracted by 1, it becomes infinity. If I say that there is a big samudra, there is a big ocean, and if I pick one drop from the ocean, will the ocean get affected? Ocean will remain ocean. So infinity, if you take 1 from infinity, he will be like, ha ha ha, take it, I am still infinity. Hai na? Chalo. Chalo, let me just, now let us do one exercise, and you guys are going to tell me that which of the following are indeterminate form. Are we ready for it? Okay. Chalo. So x tend to 1. The moment you put 1, the moment you put 1, 0 by 0. Is it an indeterminate form? Tell me. Yes or no? First wala. So 0 by 0 is an indeterminate form. So yes. Okay. Now what about this? 0 plus. So this will be 0 plus GIF upon 0 plus. So actually it is exact 0 upon 0.00 something. So this will be 0. Obviously this is not an indeterminate form. No, 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 no. What about this? Let us check. Pi by 2. So pi by 2 GIF raised to power tan pi by 2. Okay. Alright, now this is very tricky. Let's see who is going to tell me. Pi by 2 is 1.57 and tan pi by 2, so you know, not defined, or infinity also. So this is 1. Now I'm not gonna say anything. Indeterminate or not? Indeterminate or not? Indeterminate or not? Okay, so this is actually 1 raised to power infinity, but did you notice this is actually exact 1 raised to power infinity. So this is not at all. So this is actually equal to 1. This is equal to 1. This value is 1. So no, not at all. This is not an indeterminate form. Okay, not an indeterminate form. Now x tend to minus infinity. Okay, so the moment I put minus infinity, so minus infinity but square is there. So minus infinity if I put over here again, so infinity square minus 1 is infinity. If you take square root, so this expression is infinity only, and minus minus infinity. So this is not infinity minus infinity. This is actually infinity plus infinity, which is not at all an indeterminate form. So no. No, 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 no. What about this? X tend to pi by 2 minus. Okay. So pi by 2 minus, that is slightly less than 90 degree. That means in first quadrant. Okay. We are still in first quadrant. So in first quadrant, you know that tan is positive. So this is plus infinity. And this is raised to power tan pi by 2. So infinity raised to power 0. So infinity raised to power 0 is definitely a yes. So only first and last. only first and last. So in first question, Adiksha is saying, why don't we cancel this term? X minus 1, x minus 1. है ना? We can cancel. See, okay, good question I would say. Okay, we will cover it just, we have this topic actually. We just have this topic. Okay, so now we are done with the basics of limits, 7 indeterminate form also, right? So one by one we will pick the form. So we are picking with 0 by 0 form. Yes, let's start with the very first form. So like this, we are going to cover all the forms, all the 7 forms in just 4 hours. Okay, are we ready for it? So first is 0 by 0. So method to solve 0 by 0 form is factorization or rationalization. So whenever you see 0 by 0 or infinity by infinity, so you can think about this particular step, factorization or rationalization, or using substitution. So you can substitute something also. L'Hopital rule also we will study. Okay, I know that many of you already know L'Hopital rule, but we are going to keep it a little later on. Then series expansion. Okay, all right, so let us start with the very first rule, which is factorization or rationalization. Okay, so I've got one example. So one example you can clearly see, similar type of question. So limit x tend to 2. Okay, now tell me what happens when I put x equal to 2. What happens when I put x equal to 2? So if I put, ma'am, x equals to 2, I get 0 by 0. So always do this. So first step is check the form. Okay, first step is check the form. Always check the form of the limit. The moment you see JEE Main mein, JEE Advanced mein, है ना, what is a good practice? If you want to be a topper, है ना, go and ask a topper. That the moment you see what do you do in limits question, he will always tell you that I always check the form of that particular question, and based on that form I apply the method. If somebody who is forgetting checking the form, then that is not a good student, or his concepts is not clear. Okay, so if you are a Ninja Ma'am student, remember what you will do. The moment you get the question, don't just rush into solving it. Check the form. Okay, out of those 7 forms, identify the form. Okay, now x square minus 4 upon x minus 2. So this will give you x plus 2 and x minus 2 upon x minus 2. Okay, now we can only cancel x minus 2 if we are not putting x equals to 2. Understand? Because the moment you cancel, that means you are taking an oath that okay, now after this I am not going to put x equals to 2 in this. Okay, so now it will become what? X plus 2. Now you can put x equals to 2 over here, 2 point something. Sorry, no, you can't put 2, but you can put 2 point something. 2 point something will give you what? 4. 4 is the correct answer. Yes, everybody is with me. Darshan is saying, Darshan, I just told you, were you not listening? 1 power large value is always 1. है ना, तो I already told you. Let me just go back. Why you are spamming? Okay, I already told you, if it is exact 1 raised to power infinity, then this value is 1 only. But if it is not exact 1 raised to power infinity, so here it is written, na, 7 indeterminate form, it is written over here. Can you see? I already told you this is not at all exact 1 raised to power infinity. This is tending towards 1 raised to power infinity. Okay, I hope, Darshan, your doubt is clear, and also what I am teaching, pay attention. I am actually answering your question, and after that you are like spamming, huh? So yes, do not do that. I hope now your doubt is clear. Okay, chalo. है ना, तो what we were doing is factorization. So factorization में we did it nicely. Now let us do another question. Let me see how many of you are able to pull it off, how many of you are able to give me correct answer. So again, x tending towards 2. What is the very first step? Find form of this expression. The moment you put 2 over here, 2 cube is 8, minus 4, that means, and here 4 minus 6 plus 2. So can you see 0 by 0 form is getting created? है ना? So and clearly obviously the moment I put 2 in this, I am getting 0. So 2 is a root of this expression, or you can say x minus 2 is a factor of both numerator and denominator. So both will have x minus 2 as a common factor. Obviously x square minus 3x plus 2 can be factorized very easily, and I can write it as x minus 2 x minus 1, right? But what about numerator? Because there is a cubic equation, so we have to factorize. So either take the help of long division method, or what you can do is you can just directly also do it. It will require a little skill. So x minus 2. Now we need to create, what should I multiply in x minus 2 so that I get this? So obviously there will be a quadratic, so x square. So now x square into x is what? X cube. But after that you are going to get minus 2x square. But here you don't want any square term, so that's why plus 2x. Now just multiply. So ma'am, x cube, yes ma'am, plus 2x square, yes ma'am, minus 2x square, okay ma'am, minus 4x, okay, and now to minus 4x is there, but you want so plus 2. Now tell me, है ना, also 2 2s are minus 4. Now if you multiply these two, you will get this, okay? So x minus 2 cancel. Limit x tend to 2. Correct? Now you put 2 over here. So 4 plus 2 whole upon 2 minus 1 will give you 4 or 4 8. 10 upon 1. Okay? 10, 10, 10. Everyone using L'Hopital. I know. But I mean, I just want, because in limits what happens now, we are so used to short tricks, but whenever a conceptual question comes, all these fundas, all these concepts will help you out, okay? So this is why I also can apply na L'Hopital. What do you think? I don't know L'Hopital. Synthetic division also you can do. Chalo, let's solve the next question. So in this question, sometimes what we can do is we can substitute also. Yes, substitution also works. So limit 1 minus x raised to power 1 by 5 minus 1 upon x, right? So this is what we need to figure out. Now what we can do is, this 1 by 5 is troubling us, right? So why don't we do one thing, 1 minus x raised to power 1 by 5 can be put as t. Yes, okay, so this will be t. And if I just take power 5 on both the sides, I'm gonna get t raised to power 5. And this is 1 minus t raised to power 5 is equals to x. Okay. So now limit will be completely in terms of t, right? So this whole thing will become t minus 1. And this x will become what? X is 1 minus t raised to power 5. And instead of limit x tend to 0, now the moment you put x equals to 0, here if you put x equals to 0, your t will become 1. So t tending to 1. Now tell me which form are you able to see? 0 by 0, right? So limit, this is t minus 1. So why don't I do one thing, t minus 1, t raised to power 5 minus 1. So both again synthetic division also we can do same thing. Same thing is getting formed over here, or you can apply L'Hopital also. But right now I'm not using L'Hopital. So minus t minus 1, and here I'm splitting this, factorize. Obviously t minus 1 is factor of t raised to power 5 minus 1, and now this t. So obviously t raised to power 4, but I am getting minus t raised to power 4 as well, so plus t cube. Because plus t cube into t will become plus t raised to power 4, it will get cancelled out, then plus t square plus t plus 1. That's how you write, okay? Alright, now that can you see these two are getting cancelled out and limit t tends to 1 is already there. So minus 1 upon, the moment you put 1 in place of t, can you see 5 1s are there? So this is minus 1 by 5, okay? Option B is absolutely right. Clear? Yes, all right. Easy question, I would say. So B option is absolutely correct. Okay, another way is apply L'Hopital, that we are going to study and come back and solve it with the help of L'Hopital. Now this question, so substitution है ना, so what we were doing is factorization we have done, factorize and find the answer. Now substitution. So whenever you see such a complex expression, especially when the powers, can you see that the powers is something, then you have to put something like something is equals to t. So over here what we are going to do is, first of all let's check the form. The moment I put 2 over here, tell me, so 3 ka square is 9 plus 3 minus 2, 3 raised to power 1 minus 12 upon 3 raised to power minus 1 minus 3 raised to power minus 1. So this is 0 by 0 form. 0 by 0, are you able to follow me? Are you able to understand? Because you must be thinking, ma'am, why are you wasting time? Why are you checking form? No, this is a good practice. What I am telling you, I don't want to waste anybody's time and I don't want to waste my time also, no? But I am telling you this is a very good practice. Always check form, okay? Let us see how many of you remember also, huh? Chalo, now here I can clearly see 3 raised to power minus x by 2. Why not I do one thing? I put 3 raised to power x by 2 is equals to t. Let us substitute it. So now limit. Now this x tend to 2 will also change. So limit t tends to. So the moment you put x equals to 2, so when x is 2, so what will happen? 3 raised to power 2 by 2 is 1 is equals to t. So your t is 3. So limit t tends to 3. Right? And now 3 raised to power x. Can you see the moment I square it, 3 raised to power x is equals to t square. So 3 raised to power x is t square. Right? So this is your t square plus 3 raised to power 3 minus x using laws of exponent. 3 raised to power 3 minus x is what? 3 raised to power 3 upon 3 raised to power x, and this is t square. So 27 upon t square, right or not? 27 upon t square minus 12 upon 3 raised to power minus x by 2. Okay, so 3 raised to power x by 2 raised to power minus 1. So this is actually t raised to power minus 1, 1 by t. So this is your 1 by t. 1 by t minus, this is 3 by 3 raised to power x. So 3 by 3 raised to power x, and 3 raised to power x will be replaced by t square. Are you able to convert everything in terms of t? Any problem? Any issue? Okay. Factorization of last problem. Okay. Now what we need to do is just simplify it. Okay. So this is t raised to power 4 plus 27 minus 12 t square upon. So t square will get cancelled out. And here if I take LCM, what will happen? T minus 3. That's it. Is it so? Yes. Now this is actually, this also can be splitted. Right? This also can be splitted. So this, if you follow it, this is t raised to power 4 minus 12 t square plus 27. This is t minus 3. Obviously limit t tend to 3. So this is actually t square minus 9 and t square minus 3. Remember I told you now how to split. 27 is 9 3s are 27 and 9 plus 3 is 12. So t square minus 9, t square minus 3 upon t minus 3. Limit t tend to 3. Correct? Yes. So this is t square minus 9 will be what? Tell me. T square minus 9 will be what? T square minus 9 will be what? T plus 3 and t minus 3. And t square minus 3 for now, let's keep it as it is. And this is t minus 3. And limit t tends to 3. So obviously we are going to cancel this. Cancel what? T minus 3 and t minus 3 will get cancelled out. Yes. So 3, the moment now we would put 3 plus 3, and this is 3 ka square minus 3. So 6 into 6 will give you 36 as the final answer. Okay. All right. Yes, Darshan, what happened? है ना? So what did we do in this question? We just figure out a small hack that substitute 3 raised to power x by 2 equals to t. Okay. So this is t square. Why? Because the moment you square both the sides, you are going to get 3 raised to power x and t square. So 3 raised to power x, whenever you see, put t square. So this is your t square, right? And this is your 1 by t. So t square and 1 by t sorted. What about this? So this is 20. So this is actually 3 power 3 upon 3 power x. Laws of exponent. So 27 upon 3 raised to power x. So 27 upon t square minus 12 as it is. Now what about this again? 3 raised to power 1 upon 3 raised to power x. So 3 upon t square. Now we are very clear. Just take LCM. The moment you take LCM, you are going to get this. Now factorize the numerator. The moment you factorize, you are going to get this. Further, if you factorize this term, t minus 3 will get cancelled out and you are here to put t is equals to 3. Okay. Alright. Now the next problem. Okay, now this is a very good problem. Yes. Very good problem. So limit x tend to minus 2. Okay. X tend to minus 2 of this expression exists. Acha, so limit, they are giving that limit exists. Now what is the condition of limit to be exists? So let us check na form. I always say, whenever you get limit question, always check form. So numerator ko let's see baad mein. Let's talk about the denominator. If I put minus 2 over here, what do I get? I get minus 2 if I put now. So minus 2 ka square 4, correct? Then minus 2, then minus 2. So we are actually getting a 0 over here. What about the numerator? So the moment I put minus 2 over here, 4 3s are 12 minus 2a plus a plus 3, correct? Which is going to be equal to what? 12 plus 3 is 15 minus a. Okay. So basically the numerator is 15 minus a and denominator becomes 0. This is the form. This is the form. And now they are saying that, okay, this limit exists, then the value of a, okay, if the value of a is 10, for example, then the form of this limit becomes what? So if a is 10, then ma'am, the moment you put 10, 15 minus 10 is 5 by 0, 5 by 0 is infinity. So if this value, expression of this value becomes infinity, then limit will not exist. Remember infinite limits. Okay, acha. So we have observed that because the denominator is 0, now if the numerator becomes finite, then we are to gone. Then limit will not at all exist. Because if denominator is 0 and numerator is finite, then the value of this expression becomes infinity, and if limit value becomes infinity, limit does not exist. Yes? Okay, change the color. It is not visible. Kya? Okay, sorry. So what I have written is this. Just I have put x equals to minus 2. Put x equals to minus 2. So 12 minus a minus 2a plus a plus 3 upon, this is 4 minus 2 minus 2. So this is your 0 and this is your 15 minus a. Right, so what I am saying is your denominator is 15 minus a and your denominator is 0 and numerator is 15 minus a. If you put a is equals to 10, then your numerator becomes finite and limit will not exist. If you put 15 over here, then a is equals to 15, then 0 by 0 form will get formed, and 0 by 0 form will get formed. That means that limit has a chance of existing. So B can be the option, rest every option will be rejected. Do you understand the reason why? Do you understand the reason why? Now do you understand? Because Acha, Vijshri is saying limit value infinity. How can you say limit does not exist? Vijshri, do you remember we were talking about LHL limit and RHL limit should be equal and it should be finite. And if this is true, then only limit will exist. If the expression value becomes infinity, then limit will not exist. Yes or no? Very simple concept. So here what is happening, the moment I put minus 2 over here, I am going to get this. And if I put a is equals to 10, then what will happen? This will become 5 by 0, which is infinity. So any expression, if it is becoming infinity, infinite limit concept says that limit will not exist. That means it has to be indeterminate form, any indeterminate form. Now the only option I am having is a 0 by 0 form. So 0 by 0, we need to just create that form 0 by 0, that's it. That's it. Okay. Alright, so 15 is the correct answer. Correct? Okay. Ma'am, I can understand lecture very clear but confused what to do after your lecture solving P by Q. Okay, so we also have a book, Tattva book. You can have a Tattva book wherein you can just solve P by Qs. Solving 5 years, last 5 years P by Q is more than enough. Okay, but like you have to solve it very like nicely. You can't just solve it randomly. You have to have all the concepts clear. If you're not getting anything and still I have solved it, no. So solving P by Q is also an art. ठीक है, चलो. Yes, Vijay, limit value is only finite. Yes, we studied also, no? Where were you? Remember, we understood, I already clearly told you that limit value. Let me just go back to the definition. What are you doing today, huh? What are you guys doing? Let me just go back to the definition, back to basics. Can you see I have clearly written over here, left hand limit, right hand limit is equals to L and it should be finite. Then only we can say that limit exists, otherwise limit will not exist, okay? Now another question, because we have so many questions to solve. Now who is going to tell me this, about this? Yeah. Now there is a question, I want you all to solve it. How to complete backlogs? Darshan, I guess this row series is enough to complete your backlogs also. Who is going to tell me the answer of this problem? Again another student asking, can limit value be infinite? No. I mean, yes, limit value can be infinite, but in that case limit will not exist. Value to can be infinite, na? But limit will not exist. Now rationalize, which she is saying, rationalize, okay? But I have always taught you one thing, that always check form of that limit. How many of you checked the form of this limit? Okay, so 0 plus, put 0 plus, 0 plus upon. If you put 0 plus over here, 4 minus 0 plus, so this is root 2, minus 0 plus. Now put 0 plus, approximately 0. This is your root 2, sorry, root 2 need 2. 2 minus 0, so this will give you 0 as the answer. So basically, you were checking the form and you realize the expression value is 0 only. You don't have to apply any like factorization, rationalization, substitution. Why? Because this is not at all an indeterminate form, right? So you always like solve actually. So we are method to solve indeterminate form. So we are studying methods to solve indeterminate form. And if it is not at all an indeterminate form, do you even need any method? No. Right? Clear? Chalo. Now there is one question which was asked in JEE Main 2019 and JEE Main 2024 as well. Yes, JEE Main 2019 maybe they were asking this, and in JEE Main 2024 also they were asking this. Okay, I will show you the 2024 question also, because they were asking one another limit also. So let us just first do this. Okay, so always extend to 0, always check the form. Now verbally you check the form. Sin 0, so numerator is 0, denominator is what? Root 2 minus cos 0 is 1. So 0 upon root 2 minus root 1 plus 1. So this is a 0 by 0 form. So we have understood that how to solve 0 by 0 by rationalization or factorization. So here we need to apply rationalization. Okay, chalo, let's start. Sine square x upon root 2 plus minus, है ना, root 2 minus root 1 plus cos x. So what I'm gonna do is I'm gonna multiply it with conjugate. Okay, root 2 plus root 1 plus cos x and root 2 plus root 1 plus cos x. Limit x tend to 0. Can I do that? The whole sole purpose of rationalizing is what? Combining this and this. Okay, so a plus b, a minus b, a square minus, correct? This is isolated root 2 plus root 1 plus cos x, copy pasted, and this is sine square x. Now can you see sine square x can be written down as 1 minus cos square x. But ma'am, why are you even writing it? So this will become what? The denominator will become 2 minus 1, so 1 minus cos x. Now you understand why I wrote sine square x as 1 minus cos square. Now we can split also. 1 minus cos x, 1 plus cos x, and this very value which is root 2 plus 1 plus cos x. Okay, this and this is cancelled out, limit x tend to 0. So the moment now you put 0, now it is never 0 by 0 because you cancelled this factor which was making this expression 0. So the moment you put 0, 1 plus 1, and this is root 2 plus 1 plus 1, that's it. So this is going to be 2, and this is root 2 plus root 2, 2 root 2. So this is your 4 root 2. Which answer is correct? Option C. Yes, Tirthankar, if it is giving you correct answer, you can do that. D बोल रहे हो Vijayश्री, what happened? Why D? Why D? 4 root 2 is correct, right? 4 root 2. Now remember this result. Will you remember this result? Because this was the similar question is asked in JEE Main 2024, which we are going to do it. Okay, now one more question. One more question. Let's see how many of you are able to do it. The very first step. The moment you see this question, first of all, please understand what form is that. So 1 if you put, 3 minus 8 plus 1, 9, 3, 5 minus 5. So ma'am, 0 by 0 form. So why not rationalize it? Why not rationalize it? Okay, so let's start rationalizing. 3 minus root 8x plus 1. Okay, and 5 minus root 24x plus 1. Okay, now rationalizing. So now we have to double rationalize. Yes, numerator and denominator both. So what I'm going to do is I'm going to multiply and divide conjugate of it over here. 3 plus root 8x plus 1. 3 plus root 8x plus 1. Correct? And I am going to multiply 5 plus root 24x plus 1 and 5 plus root 24x plus 1. Correct? And this is limit x tend to 1. Okay. Now can you see that these two things will be combined? A minus b, a plus b, and these two things will be combined, a minus b, a plus b again. Yes, let's do that. Okay, chalo. So 3 minus this and 3 plus this. A minus b, a plus b is a square minus b square. So 3 square will be 9 and root 8x plus 1 square will be 8x plus 1 upon. Now a plus b, a minus b. So 5 plus 5 minus a plus a minus. 5 square is 25 minus square of root 24x plus 7 is 24x plus 1. but I will have two more factors pending, this one and this one. Let me just write it down over here, which is 5 plus root 24 x plus 1 left out, and this is 3 plus root 8x plus 1 left out. Yes, understanding? This is limit x tend to 1. Correct? Okay. So 9 minus 1 is what? 8 minus 8x, and this is 24 minus 24x. Okay, ma'am, now we are getting. And this is the same copy pasted, copy paste. Copy paste, I'm not writing, same we will be writing. Okay. Now limit x tend to 1, can I take 8 common and 24 common? So 1 minus x and 1 minus x will get cancelled out, and we are left with only this term, which is 5 plus root 24x plus 1 and 3 plus root 8x plus 1. And now finally what we are going to do is putting x equal to 1 over here and here. Okay, so this is 8 by 24, so 1 by 3. Multiply, now you put 1 over here. The moment you put 1, 24 plus 1 is root 25. So this is 5 plus 5, and this is 3 plus 8 plus 1 ka root is 9. 9 root is 3. So this is 1 by 3, 10 by 6. So this will give us what? 5 upon 3. 3s are 9. Anybody? 5, ma'am, it's 5. मैम इट्स 5, तो 5 ही तो लिखा है मैंने. फाइव ही तो लिखा है मैंने. हैव आई डन एनीथिंग रॉन्ग क्या? 5 by 9 इज एब्सोल्युटली राइट ना मैम. इट्स 5. इज इट 5? अच्छा, you are asking me the answer. No, 5 by 9 is the correct answer. Okay, check the calculation. Check the calculation. Friendly soul is saying I made a mistake. Yes. Okay. All right. Understood kya? Even if you made a mistake, just tell me. All of you, now you got it. Now you understood your mistake. Yes, I can see 5 by 9. So many 5 by 9. Okay. So yes, do step by step. In the beginning, na, do step by step. Because once we understand some concept, now we are like, I am the pro. I am the pro. I am like very closer to Newton. Now I am gonna solve it mentally. But just go slow. Go slow. Okay. Do not rush. Do not rush in skipping the steps. Okay. Because it will lead you to the calculation mistake. Now I was telling you this question. This is from another we will solve. Yes. So this is question from JEE Main 2024 January attempt. Yes. JEE Main 2024 January attempt. Okay. Let us see what this question has to offer. And I told you, the same question was there in 2019. So this was the question. Remember, we right away did this similar question. Let me just go back. B is equals to limit sine square x root 2 minus root 1 plus cos x. This is B. And the value we calculated is 4 root 2. Do you want me to calculate one more time? No, no. Let me just go back. Okay. This was the question. This was the question. Na? We calculated 4 root 2. Okay. Okay. Yeah. So now we have to solve only this part to get 2024 question correct. Yeah, I am giving more questions. Yeah, we will do a lot of questions. Do not worry, Gunjana. I have kept a lot of questions. Okay. All right. Yeah. So this A is something which we need to focus on. If I figure out A, then we are done. So this is again root 1 plus x raised to power 4 minus root 2 upon x raised to power 4. Correct? Again, what we need to do is, we have to rationalize it. Okay, but there are multiple square roots involved. Actually this might confuse you because plus and this thing are same. So this is 1 plus square root of 1 plus x raised to power 4. Correct? Okay. Now let me just rationalize it. How do you do that? So we need to multiply and divide conjugate of this. So square root 1 plus square root 1 plus x raised to power 4 plus root 2, and same thing I'm gonna write over here, 1 plus 1 more square root. Okay, go slow. Can you see how slow I am going? Properly I am writing everything. है ना? Otherwise you tell me I तो can do ना in one single step. I'm doing it since 10 years. Okay. Now again rationalization done. So a minus b, a plus b. So a square. So a square of this. So we will get rid of the bigger square root. So 1 plus square root of 1 plus x raised to power 4 minus square of this, the root 2 square. Root 2 square is 2. Can I just directly write it? Are you having any problem if I write it directly? A minus b, a plus b, right? A minus b, a plus b, and this is x raised to power 4. And one more thing is pending, which is square root of 1 plus square root of 1 plus x raised to power 4 plus root 2. And obviously limit x tend to 0. Correct or not? This is minus 2. Now a is equals to limit x tend to 0. Okay. Now 1 minus 2 will become what? Minus 1. So now this will become square root of 1 plus x raised to power 4 minus 1 upon x raised to power 4 and square root of 1 plus square root of 1 plus x raised to power 4. Copy paste. This is what is remaining portion. Now one more time I have to rationalize. Oh, one more time I have to rationalize. है ना? One more time. Can you see? Because I want to get rid of this, because right now also it is not resolved. Okay, so what I'm going to do is I'm going to multiply square root of 1 plus x raised to power 4 plus 1, the conjugate of it. And this is square root of 1 plus x raised to power 4. इधर लिखते हैं. Exit हो गया क्या? हाँ, 1 plus, so same thing actually I am getting. So what I was doing is rationalization, right? So I am going to keep same thing over here in multiplication. That would be this. Now again a plus b, a minus b on the next slide. Are we ready for it? A minus b, a plus b. So that will give me what? A square. So 1 plus x raised to power 4 minus b square, that will give you 1. So this is just your numerator. What is your denominator? So x raised to power 4 was already there in your denominator, and the two expressions, right? So this is your multiplication. This is your multiplication. So now let me write square root of 1 plus square root of 1 plus x raised to power 4 plus 1. This is one of the expressions, and the another expression is this. Limit x tend to 0. Now you just have to put, okay, 1 cancel, x raised to power 4 and x raised to power 4 cancel. Now you don't have to do anything. Put x equals to 0 right away. So 1 upon x ko 0. So square root of 1 plus square root 1 is 1 plus 1. Okay. What about this? The moment you put 0, the root 1 plus root 1 is 2. So this is 1 upon This is root 2, right? Huh. This is root 2. So root 2 plus root 2 is 2 root 2 and 2. So this will give you 1 by 4 root 2. Okay. So B was coming out as 4 root 2 and A is coming out as 1 by 4 root 2. Right? B is what? B is what? 4 root 2. A is 1 by 4 root 2. Now what are you waiting for? They are asking you about AB cube. So AB cube will be 4 root 2 into 1 by 4 root 2 cube. This will give me what? Batao. So this is 1 upon 4 root 2 square. 4 4s are 16, 16 2s are 32. 32 is the correct answer? Yes. Option B. All right. Give me a big thumbs up if you have understood this. This was actually tricky. This is simple. This was tricky because multiple times you have to do the rationalization. If you do twice rationalization, there are chances that you might make calculation mistake. Okay? But easy question. Overall, not a very difficult question. Doable. If you master the limits, then you are able to do it. Now some standard limits that you have to remember. Okay? Here are some standard limits. The very first is this, which is sin x by x. Sin x by x, yeah. So basically limit of sin x by x where x is tending towards 0, this is very important, is giving you 1. So let me just write it down. Sin of 0 by same 0. Same 0, okay? Sin of 0 by same 0 is equals to 1. That is your first limit that you have to remember. Okay? Second is again tan of 0 again by same 0 is also 1. Okay? Sin 0 by 0, tan 0 by 0. Then we have, okay, then we have exponential limit. Okay, let me just, after doing this now, let me just, let us solve only these two. Now let us solve the problems. First question, can you just tell me what is the answer? So x tend to 1, always check the form first. So the moment you put 1, this becomes 0 and this also becomes 0. So don't you think this is getting same sin of 0 by 0, and also here the 0 is also same as this 0. So that means this will give you a 1. Easy peasy. What about this? What about this? Sin 2x x upon tan 3x. Sin 2x upon tan 3x. So again, sin of 2x, so sin of 0 is there, but what I need is sin of 2x by 2x. This is what I need. Limit x tend to 0. And here tan 3x. So 3x, right? So what I have done is I have divided the whole equation by 2x and multiplied by 3x. So I need to do the reverse also. If 3x is there, I need to do the reverse work also. So that 2x cancel out, 3x cancel out. So that finally we are left with sin 2x by tan 3x, correct? Now this limit is 1. This limit is also 1 because sin 0 by same 0 is 1. Tan 0 by same 0 is also 1. X we can cancel out, and this is going to be 2 by 3. Okay? Now 3 by 2 is somebody study with me, absolutely wrong. 2 by 3 is correct. Okay, so let me just give you this shortcut. Ninja technique, let me give you ninja technique. What is ninja technique? So sin ax upon tan bx or tan ax upon sin bx. Okay, obviously when x tend to 0, you can directly write it as a by b when x tend to 0. Directly A by B. So can you see directly, you don't have to do it. 2 by 3 is the final answer. Cut, cut, cut. Ha, ProCuber, you are absolutely right. We make sin x approximately equal to x. That's why it is happening. Now, okay. Now one more, like two more standard limits. Same, sin inverse x upon x is also 1 if limit x tend to 0, and same goes with tan inverse also. Tan inverse x upon x is also 1. Okay, so 4 limits, 1, 2, 3, 4. Okay. Now who is going to tell me this? You can use shortcut also here. You can use shortcut. Use the shortcut. 5 upon 1 by 4. So 20 is the correct answer. Done, 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 done. Using the shortcut. Yes, ProCuber, absolutely right. And the actual method, how are you going to do that? So basically tan inverse 5x and sin inverse x by 4, correct? So how do you do that? You need so you need 5x in the denominator, so you have to multiply 5x in the numerator. Then you need x by 4 here, so you have to have x by 4 here. So this will become 1, this will become 1. And x cancels, so 5 by 1 by 4 will give you 20 as the correct answer. Yes, using standard limits. Okay. Now let me just tell you. Okay, so this is done. This is also done. Now I'll be talking about this limit. X raised to power n minus a raised to power n upon x minus a. So first of all, what is this form? What is this form? Tell me. So ma'am, the moment you put a in place of x, so 0 by 0 form is getting created, right? So what is the final result? So the first of all, the power will be the final result, so n. Answer will be n. Then you have a, which is like limit tending to which value? A, and power n minus 1. Okay. Shall I give you one question? X cube minus 2 cube upon x minus 2, limit x tend to 2. Tell me, how will you write? So first of all, power 3. Then this limit x tend to what? 2. And now reduce a power. So power was 3, na? So that's it. So this is 3 multiply 4. That is going to be 12. Okay. All right. Clear? Now tell me one thing. X raised to power 4 minus 7 raised to power 4 upon x minus 7. Limit x tend to 7. Are you able to tell me this? So ma'am, power aega 4. Then the number 7 and reduce a power. That's it. That's it. Okay. Easy application. Now this, who is going to tell me the answer? So this is 1 raised to power 10, no? So ma'am, we know that, okay, power 10, then number 1, then 9. That's it. So 10 is the correct answer. What about this? Ah, okay. Now what is happening? Actually, so the formula was x raised to power n minus a raised to power n upon x minus a. So this x minus a is missing. This was the formula. That is n minus 1. So this x minus a is missing. So we have to modify it a little bit. So x raised to power 10 minus 2 raised to power 10 upon x minus 2. Can I do that? I will divide x minus 2 for this expression and I will multiply it also. This is again limit x tend to 2. So this is going, now differently you put. You solve this and you solve this. Power 2 raised to power 9. Okay, what about this? This will be in denominator. Power is 5. 2 raised to power 4. Okay, so 5 2s are. So this is 2 and 2 raised to power 5. So 2 raised to power 6 will give you 64 as the final answer. Absolutely. Yes. Now one more question let us do. One more question. This is based on same previous concept. Okay. So now x tend to 0. Okay. X tend to 0. So this is actually, this, who is going to tell me this? Oh, sorry, x tend to 2. Sorry, my bad. Yes, Santosh, nice observation. Here x tend to 2 is there. If x tend to 1, then we just have to put x equals to 1 and like this is not at all an independent form. What about this? Pro Cuber is actually applying brains. Okay. So now understand x tend to 0. So this value is tending towards 0. Multiplication of this. So sine infinity. X and sine infinity. Now tell me this value fluctuates between -1 to 1. Right? So this is 0 multiply a fluctuating value which is lying between -1 to 1. Because the moment you put x equals to 0, 1 by 0 is infinity. Sine infinity will give you any value. Sine of like larger angle will give you any value between -1 and 1. So that's why this will become 0. Now you understand why I always tell you that check the form. Because we don't want to waste our time in doing some problems which is not even in indeterminate form. Just like this, that Santosh highlighted. If it is x tend to 1, it was written x tend to 1 by the way. If it was x tend to 1, then we don't have to do anything. Just put 1 minus 2 raised to power 10, 1 minus 2 raised to power 5, done. But if it is x tend to 2, then this is 0 by 0, then we need to intervene. Okay, indeterminate form hai, so we need to solve. Okay, and now this. Okay, so this is also done. Now this logarithmic limit, again a standard limit. So log of 1 plus 0 upon same 0 is 1. Okay. All right. So log. Now tell me 1 plus 3x upon x. Limit x tend to 0. Tell me this. Tell me this. Limit x tend to 0, log 1 plus 3x by x. So again, log 1 plus 0 upon same 0. So this is 3x. So I need 3x over here. So I need to multiply 3 here and 3 here so that this becomes 1. This will become 1. So 3 multiply 1 is the correct answer, 3. Okay. All right. Yes. Clear? Chalo. Now let us do this question, which is this. Log of 5 plus x minus log of 5 minus x upon x. Okay, now this is something which is a little bit tricky. All right, Srinivas, thank you so much. So this is a little bit tricky question, okay? So sometimes what happens is, because the previous question, log 1 plus 3x upon x, that was ready for you in platter. That just multiply 3 by 3 and ready-made limit is done. Okay, But in some questions, the ready-made standard limit is not created. You have to forcefully create it. Forcefully. Let me show you how are you going to do that. Okay, so log 5 plus x minus log 5. So first of all, property of log, but before that I always say form of the limit, if you check that is 0 by 0 only. Yes. So here what I'm going to do is apply property of logarithm. So log of 5 plus x upon 5 minus x upon x. Okay, so I can see that a little bit form is actually matching, because usually what happens is 1 plus x upon x is 1, and this x is nothing but 0. This is the standard limit which we are going to use. Yes, okay. So right now this is 0 and this is limit x tend to 0 is already there. So this is done. Denominator is 0. I just need the format of 1 plus some 0. I only need that, 1 plus some 0. Okay. So what we will do is, we are going to add 1 to it and subtract 1 to it. Add 1 to it and subtract 1 to it. So over here, add 1, okay. Add 1. So I am adding 1 to it and subtracting 1 to it. Okay. So now log of 1 plus, and what I'm going to do is I'm going to combine this portion. 1 plus will be remain as it is, and the remaining portion I want to club. So limit x tend to 0 log of, then it is 1 plus, then it is 5 plus x, LCM ले रहे 5 minus x upon x. Understood what did I do? So this was the expression. I just added 1 and subtracted 1. And then what I did is I clubbed them together. So take LCM. So I took LCM also. And this 1 is kept over here. Why? Because I want to make this form. Right? Now what will this become? Tell me. So ma'am, this will become log of 1 plus, now solve this out, 5 cancel, x plus x 2x upon 5 minus x upon x, limit x tend to 0. Can you see the moment you put 0, is this becoming 0? Tell me. The moment you put 0, is this becoming 0? Because I want log 1 plus 0. Okay, so yes ma'am, this is actually becoming 0. So I need log 1 plus 0 upon same 0. So why not I multiply the same factor over here and same factor over here. Right? So this will actually become what? 1. And log 1 plus 0 upon same 0 is gone. Log 1 plus 0 upon same 0 is gone. So this is 1. So we are left with this x and this. So this x and x can I cancel? Now if I put x tend to 0, this will be 1, this will be 2 upon 5 minus 0. So 2 by 5 will be the correct answer of this question, yes or no? Alright, voice is not low actually. So abhi how can I increase, because I can listen to myself. It is fine, voice is fine beta. Just change the device maybe, because I feel that your device is not fine. Everybody is commenting that voice is fine. Okay, you can ask the other students also. Now another question, this was asked in JEE Main 2014. This question was asked in JEE Main 2014. Okay. So again, what we need to do, the very first thing, we see the question, we see the expression, what do? Check the form of that limit. So ma'am, okay, x ko if I put 0 over here, denominator is so for sure 0, and the numerator ma'am sin pi cos 0 is 1. So sin pi is 0. Okay, alright, so this is a 0 by 0 form. But, and also one more thing ma'am we are observing over here is that sin pi is becoming 0. inside the sign you are not having a 0. Understanding my point? Sin pi, so inside the sign what is becoming pi, and then sin pi is becoming 0. So over here what we need to do is we need to convert this cos square x. So sine of pi, cos square x is 1 minus sine square x. Okay, and this is your x square, limit x tend to 0. So now it will become what? Sine pi minus pi cos square, pi sine square x upon x square. So this is actually becoming something. Sine pi minus theta, tell me. Sine pi minus theta is what? Ma'am, sine theta. So sine pi minus this is sine pi sine square x upon x square. Limit x tend to 0. Now you check the form. Now you will realize what I am saying. You put 0. So sine pi into 0 and this is 0 square. So now what you can do is you can multiply and divide. So inside the sign you are getting a 0. So you want a same 0 over here, so that these two quantities will be gone. And one more thing which will be left out, pi sine square x. So I am multiplying and dividing by pi sine square x. So this will become, the whole thing will become 1, because sine of 0 upon same 0. Did you notice? Sine of 0 upon same 0 is 1, right? And sine square x upon x square is also 1. So the only thing, this is also gone. This is also gone. So the only thing which is left out is pi, pi, pi. Option B, absolutely right. Okay. All right. Clear? Now let us see who is going to tell me the answer of this question, which was asked in JEE Main. Ma'am, why are we multiplying and dividing? We can approximate it. No, ma'am. That you can think as a shortcut. Yeah, if it is working for you, you can just, sin x can be written down as x, then, yeah. L'Hopital rule also you can apply, but L'Hopital rule is applicable. If you apply L'Hopital rule here, no, it will actually create a lot of issue. You won't be like, it won't be as simple, because whenever trigonometry involves, the expression doesn't get reduced. The expression only gets like more complicated usually. Sometimes it does, sometimes it doesn't. Okay. Now this question, we don't even need to solve this question, because see, whenever the question is saying see, in JEE Main you will see the options, that whether the limit does not exist or exists. So if at all in any question there is no such option where does not exist is mentioned, then you don't have to worry. But can you see, does not exist is mentioned over here, so you have to be very careful. The very first option, the very probable option should be this. You would be ruling out this, then you think about anything else. This option should be scaring you. Okay, now tell me, left hand limit if I calculate, can you just tell me the numerator part, whatever the value will it be always positive? Because square root of any expression is always positive. So numerator, no matter what, whether you calculate right hand limit or left hand limit, will always be positive. Now denominator, if I put right hand limit, if I check right hand limit, so right hand limit, if I check right hand limit, then I put 2 point something, 2 point something minus 2, 2 point something minus 2, so this is positive. So RHL is a positive value. Understanding? RHL is a positive value. What about ma'am LHL? So in LHL, numerator is anyway positive, even if it is LHL, but now in LHL, the denominator will be 1.999. right? So this value will be negative. So LHL will be negative. So can you see the value of RHL, whatever it may come, will be positive and it will be negative. So that's why limit does not exist is the correct answer. Okay, just by not even calculating, I have not calculated it. I was just trying to understand the sign of numerator and denominator. You can calculate it also, LHL, RHL, if you individually calculate now, then you will realize that no. You are doing it absolutely wrong. Okay. Alright. Let me just show you now how to do it. Chalo. So can you see that 1 minus cos 2 theta is what? 2 cos square theta. Correct? 2 sine square theta. Sorry. This is sine. You all have done like this only, right? So answer will be, so square root. So this is square root of 2 sine square x minus 2. Is it correct? Upon x minus 2. Okay. Limit x tend to 2. Now remember, I taught you this very nicely. Square root of x square is mod x. And it is not at all x. So this is mod of sine x by 2. X minus 2. 2 is already here. Upon x minus 2. Limit x tend to 2. Correct? Okay. Now, root 2. This is root 2. The root 2 is outside. Limit x tend to 2. Mod of sine x minus 2 upon x minus 2. Correct? Now again that sine 0 by 0. If you put x greater than 2, x tend to 2 plus. If you calculate right hand limit, what will happen? Tell me. So this is going to be sine of a positive quantity. Now sine of a positive quantity is the same. So this is sine of x minus 2 upon x minus 2. Root 2 is already there. So this will give you root 2. This is your right hand limit. What about left hand limit? Left hand limit. Let us talk about left hand limit. So this is root 2 limit x tend to 2. Now the moment you put x tend to 2 minus. So here you are putting 1.99. Right? So the modulus will get open with a negative sign. So this is minus sine of x minus 2 upon x minus 2. So this will give you a minus 1 into root 2. Minus root 2. And here also you can understand. Okay, so this is one way of doing it. Another way is, just tell me that this is always positive. Numerator is always positive. Yes, ma'am. Denominator for right hand limit is positive. And for left hand limit obviously will be negative because modulus is there. So again LHL will be a negative quantity. So that's why it does not exist. Okay, yes Kanha, good evening, welcome to the session. Now there was a question asked in JEE Main 2023. Let us see how many of you are able to do it. A very basic question. It looks like it is a huge question. So many terms are given, but it is not a very difficult question. Good evening, Hemant. Good evening. Okay. Chalo, let's start this question. So 1 minus cos square x. The moment I see this now, this will so sine square 3x, correct? Okay, upon cos cube 4x. This is sine cube 4x and this is log of 1 plus 2x raised to power 5. Limit x tend to 0. Okay, what I did is 1 minus cos square is sine square. Now, can you see this sine square 3x will need a 3x in the denominator, 3x square, basically. So what I need is, I need 3x. I need a 3x square and a 3x square for this. Okay, because sine 0 by 0. Correct? What about this? So again, I need a 4x cube over here in the denominator, and 4x cube I need to keep it over here. Correct? This is also sorted. Now the moment you put x0 over here, now, so this is cos 0, which will tend towards 1. So this is right away cos 0, which is 1. So this is a harmless quantity. This is not at all a standard limit or something like that. And this, again, log 1 plus 2x raised to power 5. So I am going to need 2x raised to power 5 and 2x raised to power 5. Correct or not? Yes. Now let's club them together. Sine square 3x and this. Let us club them together. Sine 3x upon 3x square. Done. This is already 1. Okay, this I am not writing, but this will become 1. Then this is sine 4x upon 4x cube. Then I need this. So which thing is gone? This is gone, and this 2x. Correct? Bracket close, limit x tend to 0. Alright. And now we are left with what? 4x, 3x, so 9x square. 4 4s are 16, 64x cube upon 32x raised to power 5. Okay, so this is your 1. This is also 1. This is also 1. So this bracket is becoming 1. What about this? So 32 ones are 32. 32 2s are 64. X cube, x square is cancelled out with x raised to power 5. 9 2s are 18 is the correct answer. Option C, 18 is absolutely right. Okay. Somebody is saying 9. You are forgetting this too. 32 and 64 too. Okay. Clear? All right. Now let us learn about a few more limits. Okay, let me give you this homework. Sorry, homework nahi. Let me give you this question. Where shall I write? Okay. Just tell me one thing. No, 1 second. Standard limits. Now, 3 more limits I want you all to know. 3 more limits. Out of which this one is my most favorite. First is limit 1 minus cos x upon x square, x tend to 0, is half. Second limit, limit x tend to 0, x minus sin x upon x cube is 1 by 6. These 2 limits, okay? Limit x tend to 0, x minus sin x upon x cube is equals to 1 by 6. Alright, so you have to remember these 2 limits, out of which the first one is my favorite, by far my favorite. Okay, alright, now I'll be having one question for you all. Let us see how many of you are able to think. Yeah, so this is the question and this was asked in JEE Main 2021. Main 2021. Okay, are we ready for it? है ना? So yes, cos sin x minus, this is actually a very popular type of question wherein they give such expression. So cos sin x minus cos x, okay, upon x raised to power 4, again 0 by 0 form. So here I'll be using this formula, which is cos c minus cos d. Anybody remember this formula? Cos c minus cos d. Cos c minus cos d is 2 sin c plus d by 2 sin d minus c sin d minus c by 2. Okay, this is the formula which we are going to use right away. So cos c minus, अरे यार ये क्या चालू हो गया? हाँ ठीक है, कैन आई अप्लाई दिस फॉर्मूला? ओके चलो, cos c minus cos d, तो मैम 2 sin and sin, okay, तो मैम 2 sin c plus d by 2, this is your c, this is your d, तो sin x plus x by 2, correct, and sin d minus c by 2, तो x minus sin x by 2 upon x raised to power 4, limit x tend to 0, correct? Okay, now what do I want? Now what do I want? Understand, sine of 0 is getting formed, right? Sine of 0 upon same 0. So I need the same thing over here, which is sin x plus x by 2, and I want same thing over here, which is x minus sin x by 2. So I have divided the whole expression by x plus sin x by 2 and x minus sin x by 2. So I have to multiply it also, right? So let us multiply it over here, which is x plus sin x by 2 multiply नहीं लिख रही हूँ, डॉट लिख रही हूँ, x minus sin x by 2, correct? Now this expression will become 1, sin 0 by 0 gone, this expression is also gone, sin 0 by 0. What am I left with is x raised to power 4 and these two chotu expression and 1 2, so 2 x plus sin x by 2 and this is x minus sin x by 2, correct? This 2 and this 2 get cancelled out, this is limit x tend to 0, and now x minus sin x, remember that limit, limit x tend to 0, x minus sin x by x cube is 1 by 6, correct? So now this x raised to power 4, I am going to distribute this over here, so this is x cube and this is x, so now x by x is what? 1, sin x by x is also 1, and this is x minus sin x by x cube is what? Tell me. 1 by 6 and a 2 is already written over here. Okay, so this 2 and this 2 cancelled out, so 1 by 6 is absolutely right, option C. Have a look, understand. Okay, clear? Good question, huh? This is a very good question. Chalo. Now another question on our screen. Another question. Okay, and this is again the similar question, x raised to power n wala. Alright, so this is equal to this. So this we can write now. X raised to power 1 0 by 0 form. So 4 1 raised to power 3 is equals to. What about this? So if I multiply x minus 1 in the denominator and numerator, so this expression will become power 3 and then k square upon power 2 k raised to power 1. So 4 is equals to 3 by 2k. K is nothing but 8 by 3. Done, 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 done. k is 8/3. JEE Main 2019 का question. What do you think? Easy question. Okay. Alpha. One more similar type of question. Let us check that what this question has to offer. Okay. Evaluate this limit. So first of all, we have to open the sigma. Sigma k equals to 1 to 100. Okay. So x raised to power 1 plus x raised to power 2 plus x raised to power 3 and all the way up to x raised to power 100 minus 100 upon x minus 1. Limit x tend to 1. Okay. Now there are 100 variables and 100 is written over here. If I distribute this 100 in every one of them, what will I get? Ma'am, x minus 1, then we have x square minus 1, then we have x cube minus 1. Then we have x raised to power 4 minus 1, x raised to power 5 minus 1 and all the way up to x raised to power 100 minus 1 upon x minus 1. Limit x tend to 1. Now tell me, x minus 1 upon x minus 1 will become 1. X square minus 1 upon x minus 1 will become what? Again, if you apply the formula, then also it is fine. Or if you can split it out. X plus 1, x minus 1. X minus 1, x minus 1 cancel. Then x plus 1 will be left out. X plus 1 is 1 plus 1, 2. Or you can apply the formula also. Power will come in front. And anyway, 1 raised to power 1. Plus here, x cube minus 1 upon x minus 1. So power will come in front. 1 raised to power whatever, it will become 1. Plus 4 plus 5 plus 6 and all the way up to 100. Last term will be what? 100. That's it. So the final answer of this question will be what? So sum of first 100 natural numbers, you know how to calculate. 100 into 101 by 2. Formula is n plus 1 by 2. We have already studied sequence and series. So this is 5050. Yes. Now two more limits, standard limits. Yes. Okay, so only two limits are remaining, this and this. Okay, these two are actually exactly same. So this is e raised to power 0 minus 1 upon same 0. E raised to power 0 minus 1 upon same 0 is 1. Okay, actually this is ln e. This is nothing but ln e. Right? And if a raised to power x minus 1 by x, so this is ln a. So because it is ln e, log e value is 1. And since this is ln a, it is ln a. Okay? Alright. Now, I will give you a question. Give me this e raised to power x square minus 1 upon x square. Limit x tend to 0. Tell me. A raised to, okay. Limit 2 raised to power x minus 1 upon x. X tend to 0. Tell me these two values. We will handle this question a little later. Just tell me this value. So again same thing. E raised to power 0 minus 1 upon same 0 is 1. Now a raised to power x minus 1 upon x is log of 2. Okay. Alright. Understood this nicely? Clear? Direct formula based. Okay ma'am. Fine. Now solve this question for me. Let us understand this question. Very basic question. So 2 raised to power x minus 1 upon this. So again rationalization. Let's take help of the rationalization. So let's multiply 1 plus x plus 1. 1 plus x plus 1. Correct? So now the numerator is to this. Okay, denominator will become what? A minus b, a plus b. 1 plus x minus 1. And what about this? 2 raised to power x minus 1, and this is square root of 1 plus x plus 1. Limit x tend to 0. Correct? 1, 1 cancel. Now 2 raised to power x minus 1 upon x. So this will give you log of 2. What about this? The moment you put 0, root 1 plus 1 will give you 2. So 2 log 2 is the final answer of this question. Easy? Clear? Now this question. Let's see how many of you are able to do this. Log 4 is also correct answer. Log 4 you can write. Yes. Okay. Now the numerator is getting factorized. How many of you can see it? This 10 raised to power x can be written down as 5 raised to power x, 2 raised to power x. Minus 2 raised to power x minus 5 raised to power x plus 1. So I'll be clubbing these two together and these two together. Okay. And upon we are having x tan x. Limit x tend to 0. So limit x tend to 0 is now 2 raised to power x. If you take common, this is 5 raised to power x minus 1 minus 5 raised to power x minus 1 upon x tan x. So this is actually 2 raised to power x minus 1, 5 raised to power x minus 1, x tan x. Okay. For this, I need one more x in the denominator. Yes, so this is done. 2 raised to power x minus 1 upon x. This is sorted. I need one more x for this. So x divided and x multiplied also. Limit x tend to 0. Okay. So 2 raised to power x minus 1 upon x is log of 2. Multiply. This will be log of 5 and tan x by x will become 1. Pranav absolutely right. Log 2 multiply log 5 is the correct answer of this question. Okay, alright. So now we have actually seen rationalization and factorization. But also these two are still remaining. Substitution also we have seen till some extent. L'Hopital and series expansion is something which we need to see. Okay, alright ma'am. So now L'Hopital rule, you know that L'Hopital rule is only applicable for 0 by 0 and infinity by infinity form. Okay, alright. Now just tell me what is the limit of this particular question. So L'Hopital rule, what is a L'Hopital rule? Just calculate this for me. So L'Hopital rule mein if you have fx by gx, right, where both fx and gx either both are tending towards 0 or both are tending towards infinity, then what you can do is you can write the limit of fx by gx, where x is tending to same number as per the question, that will be f dash by f dash g dash x. Okay, so individually numerator and denominator you have to do it. Okay, and you can just again you can further differentiate it also. Okay, alright, so Rama Lakshmi is saying -3. Some of you are saying 1 by 14, some of you are saying -3. I always do that. I always give you this googly question. The answer is not -3. Okay, so always whenever you apply L'Hopital, it is clearly mentioned over here that L'Hopital is only applicable when the form is 0 by 0. Did you check the form? Did you check the form? If you go and check the form, the value of this expression is 1 by 14 directly. The L'Hopital is not applicable over here. Okay, so 1 by 14 students are saying that is fine, that is correct. Okay, alright, I will tell you expansion we will study now, then I will tell you that how to recognize. Chalo, now using L'Hopital we have to get this answer. Using L'Hopital, can anybody tell me? Get this answer for me using L'Hopital. Log of tan square 2x upon tan square x. Okay, x tend to 0. So limit x tend to 0. This is, so by base changing theorem, I will apply base changing theorem. Log of tan square 2x upon log of tan square x. Okay, this is by base changing theorem, है ना? Base changing theorem I have used. Now one more property of logarithm, whenever there is a power on the number, this power will come in front. So this 2 we can call it in front, this 2 also we can call it in front, this 2 cancel. So limit x tend to 0 finally. Log of tan 2x upon log of tan x. Now you can apply L'Hopital. Now you apply L'Hopital. Okay, now you apply L'Hopital. So L'Hopital mein you have to differentiate it. Log of any quantity, derivative of log x is what? Chain rule we are applying. So 1 upon tan 2x. And the derivative of tan 2x is sec square 2x. And the derivative of 2x is 2 upon. Now again, log of tan x, derivative is 1 upon tan x. Derivative of tan x is sec square x. Derivative of, now that's it. So the final answer will be what? Now you put x equal to 0. The moment you put x equals to 0, this will become 1. This will also become 1. So these two are gone, 1, 1. This is your 2, correct? 2 is kept over here and this is tan x upon tan 2x. Okay? Alright, so the answer will be what? You multiply 2x by 2x, so 2 by 2 is the answer. That is going to be 1. 1. Okay? Anonymous is saying base changing theorem, how to decide the base. You don't have to decide the base, okay? So you don't decide the base. I have taught this in logarithm. If any base given in the question, apply that base. If no base is given in the question, do not apply the base. Can you see? I have not even written the base. I have written log, ln, natural logarithm you can write, and if you don't want to write, keep it log only. Okay? And like last step mein you can decide. Last step mein you decide it. It will be very intuitive. Do not even bother about deciding base. Once you are done with the question, then you think, now what should be the base? Any base you can keep. Okay. Now there are a few problems from L'Hopital, which is This was asked in JEE Main 2011, very old question, and the similar type of question they were asking in this in JEE Main 2021. Can you see, just over here A is replaced by 2. Whether you want to do it, or you want to do it, okay? Any of these two will work. Chalo, let's do it. Let's do JEE Main 2021. If you do it, that question will also be done. F of 2 is equals to 4, है ना? First of all, check form. F of 2, if you keep, okay, so check form. Form, ma'am, form of this limit is 2 square is 4. F of 2 is, ma'am, again 4 minus 4 into fx. Acha, so 4 into fx is again 4 upon 2 minus 2. So, ma'am, 0 by 0, apply L'Hopital. Apply L'Hopital. Okay. So, L'Hopital, if you apply over here, limit. L'Hopital rule, if you apply, limit x tend to 0. How to apply L'Hopital rule? Differentiate the numerator. So, x square f of 2. F of 2 is constant. Derivative of x square is 2x. Correct? Minus, and f of 2 is constant. F of 2, let's keep it constant over here. F of 2. Correct? Minus, this time 4 is constant. Derivative of fx is f dash x. Upon x minus 2, derivative of x is 1, 2 is 0. Now you put x equal to 2 over here. The moment you put 2 2s are 4 times f of 2 minus 4 times f dash 2. Now you have the value of f of 2 and f dash 2. So 4 times 4 minus 4 times 1, 16 minus 4 is 12. 12 is the correct answer. Twelve is the correct answer. Got it? Yes? Clear? Same type of question was asked in JEE Main 2011. Again, here x is replaced by a. So yes, differentiate it. So 2x f of a minus a square is as it is f dash a. Okay, f dash x, and upon 1. Limit x tend to a. Now you put x equals to a. So 2a f of a minus a square f dash a. That's it. This is your answer. Here no values are given, so final answer is this only. Just differentiate, put x equals to a. Okay, so options were given just like this, so you have to take the correct answer. Now, can you see L'Hopital rule? So the standard limits we studied, na, that is actually L'Hopital rule. Apply L'Hopital over here, sin x by x. So ma'am, L'Hopital, if I apply cos x by 1, derivative of sin is cos. Derivative of x is 1. Cos x by 1, so cos 0 is 1. Now you know, apply L'Hopital. So this is cos x by 1. So this is cos 0. So that is 1. Now again, this is sec square x by 1. Sec square 0 is again 1. Right? So that's how you obtain. Now again, 1 minus cos x upon x square. So again, what you can do is, so you can just minus sin x upon 2x. Okay? No, sorry, plus sin x. Cos x ka derivative is minus sin x. One more minus sign is already here, so plus sin x. Now can you see this is half? है ना? So you can just verify this also. We are verifying, nothing else. Apply L'Hopital. So 1 upon 1 plus x. Derivative of x is 1. Now put x equals to 0. You will get 1. What about this? E raised to power x minus 0 upon 1. Now you put x equals to 0. You will get 1. In case you forget the value of any limit, what you can do is, you can apply L'Hopital. Acha, tell me. Two very important. This is my favorite, okay? Two very important questions. X minus sin x by x cube, limit x tend to 0, and x minus tan x upon x cube, limit x tend to 0. Can you tell these two values of limit using L'Hopital? Using L'Hopital, can you take these two? So ma'am, if you apply L'Hopital in this, what do you get? Ma'am, 1 minus cos x upon 3x square. Oh, now you can use standard limit now. So ma'am, 1 minus cos x upon x square, so 1 by 3 into 1 by 2. Ma'am, 1 by 6. Remember I told you to remember this limit. What about this x minus tan x? So again you have to apply L'Hopital over here. So 1 minus tan x ka sec square x upon 3x square. Clear? So 1 minus sec square x. Now what you can do is, you can just convert this to 1. So actually this is cos square x minus 1 upon cos square x and 3x square. So this is actually minus sine square x. So minus sine square x upon this is cos square x. Actually directly you can write it here only na. Oops. No need of doing this. Tell me, sec square x minus 1 is what? Tan. So this is minus tan square x upon 3x square. So this is minus 1 by 3. So this value is minus 1 by 3. Okay. Alright. So these three limits are important limits. Okay. 1, 2 and 3. This you will not find in books ki this is standard limit. But I to say ki you should remember it. Okay. Now before heading towards series expansion, I have two questions to give you. Okay, let me give you two questions. है ना? Let me give you two questions. Yes, this question I want you to solve. E raised to power x square minus cos x upon x square. So now you know that the standard limit would be what? E raised to power x square minus 1. It should be minus 1. So what I'm going to do is, I'm going to do minus 1 and plus 1. Can we do that? Minus 1 and plus 1. If it works for us, why not? So I did a minus 1 and a plus 1. It will actually help both the parameters, exponential also, cos also. Now tell me, so e raised to power x square minus 1 upon x square, this is your 1 plus 1 minus cos x upon x square. This is limit x tend to 0, limit x tend to 0, right? Okay, so this is 1 plus half, that will give you 3 by 2. Okay, another question on your screen, which is this. Now this type of question I want your maximum attention over here. Okay, anybody who is listening right now, you just listen to this carefully. Okay, so this says that e raised to power tan x minus e raised to power x upon tan, again 0 by 0 form. So whenever you see, very important type, whenever you see two exponential together, can you see in the numerator two types of exponential can be seen together? Always remember, take the second exponential common. I am telling you the trick. Trick is what? Take the second exponential common. Take second exponential common. What is second exponential? Batao. E raised to power x. So you have to take e raised to power x common. Okay. So if you take e raised to power x common, so it will become e raised to power tan x minus x. Yes or no? This is how you take common. Anybody having problem with taking common? Now you multiply and cross check. So if you multiply e raised to power x, e raised to power tan x minus x plus x will get cancelled out, and this will become e raised to power tan x. If you multiply this over here, you will get this. This is how you take common. Okay, upon, this is tan x minus x. So you have taken e raised to power tan x minus x common. Right now, can you see e raised to power 0 by same 0 is getting created. So this will become 1. So this is going to become e raised to power 0, that is 1 is the correct answer. Done, 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 done. Yes or no? Clear? 1 is the correct answer. Okay, now let us move on to the series expansion. Let us talk about the series expansion now. Shall we take a small break? No, small nahi, let us take a full break. So let's meet at 8:55. Okay, so let's resume at 8:55. Okay, all right. So we're studying since 2.5 hours. Monster, you are here. Chalo. आ गई, I am back. Okay. All right, series expansions. Let's start. All right. Okay. All right. So series expansion में, if you know this Maclaurin series na, then you will be able to understand that from where the series is coming from. But you have to remember the series. Yes, there is no like substitute that ma'am we will remember only this and then we will figure out in exam. No, I strongly recommend you all to at least remember all the expansions which I am listing right now. Okay, it will actually make your job very easier, right? So whenever you get stuck in any limits question, any basic limits question, remember expansion will help you out. Okay, chalo. So e raised to power x expansion, that is 1 plus x by factorial 1 plus x square by factorial 2 plus x cube by factorial 3. This is the very first expansion. Will you be able to remember it? Yes. The next expansion is a raised to power x. Actually, if you remember this now, remembering this is not at all difficult. You just have to replace x by x ln a. Replace x by x ln a. X square by x ln a whole square. Just that, can you see? Very beautiful, very easy. Now the third expansion, very important, is ln 1 plus x. So ln 1 plus x will give you alternate plus minus sign. Remember, e raised to power x mein there is all factorials. All the powers are there, positive numbers, everything is positive. And power 0, power 1, power 2, power 3, increasing powers are here. Okay, same this. Now ln 1 plus x, no factorial, and it start with x. So x minus x square by 2 plus alternate plus minus sign, can you observe? X minus x square by 2 plus x cube minus x square power 4 by 4 and so on. If I ask you what will be the expansion of log of 1 minus x, will you be able to write it down? So you just have to replace x by minus x. So all the terms will be negative, minus x square by 2 minus x cube by 3 minus x to the power 4 by 4 and so on. This is how your log 1 minus x look like. Okay, all right. Now some more expansion, basically the trigonometric expansion, sin x. Now remember, sin x is an odd function. Odd function means all odd powers. Odd powers starting from 1, 3, 5 and so on, right? So this is plus minus and so on, sin x. Then cos x is even power. Even power, can you see, starting with x raised to power 0, square power 4, alternate plus minus sign. So if you remember sin x, now cos x will be automatically done, right? Why? Because odd power, even power, again alternate plus minus sign, the power and the factorial are matching, 2 factorial, 4 factorial and so on. And last, tan x. So tan x ka there is no such pattern which can be observed, like the pattern observation will not help you out, but if you can remember only 3 terms now, then also it will help out. Okay, tan x very rarely used, but if you are getting stuck, then this will actually help you out. Tan x ka x plus x cube by 3 plus 2 raised to power x power 5 by 15, again all the odd powers, 1, 3, 5, positive sign 1 by 3, 2 by 15. Okay, all right. Then we are having a binomial expansion, that we will talk about it later. Let's solve a few problems from expansion. Okay, are we ready for it? Ready? PYQs, yes, we are doing PYQs also, and we'll be coming up with all chapter 2024 all PYQs also, है ना? So do not worry about that. So this road series is all about concepts plus PYQs, and there will be one more PYQ series which we will be launching by the end of the July, before end of the July. All the 2024 PYQs will be there, and after the class we are providing DPPs also. So DPPs I'll be giving you like 2-3 days later after this session. Okay, all right. Yes, e raised to power x minus minus 1 minus x this. Now apply the expansion. Applying expansion of e raised to power x. 1 plus x square by 2 factorial plus x cube by 3 factorial, and it will go all the way up to infinity. This is the expansion of e raised to power x. Minus 1 minus x, let's keep it as it is, upon 3x square. Limit x tend to 0. Correct? 1 and x is getting cancelled out with 1 and x. And you are left out with what? So again, x square plus x cube, this is 2, this is 6 upon 3x square, and it will go all the way up to infinity. Limit x tend to 0. Tell me, now what will happen? X square upon x square will become cancelled out. So it will become 1 by 6 plus, can you see this is x by 6 3s are 18, and this will become 0. Why? Because x is tending towards 0, so you put 0 and all the rest of the terms will become 0, 0, 0. So final answer will be 1 by 6. Okay. So one very important tip to notice, that whenever you apply the expansion, so you go only up to x square, like in this question, because the denominator is having x square now, so you only open till x square. You don't need to write this. Okay. So what is that trick? If you want to apply the expansion, expansion goes up all the way up to so many terms are there, but you don't have to write all the terms. Just write only those terms till you reach the power of denominator. Okay. All right. Yes. So chalo, let's see now this question. So first of all, let us solve this out. Again 0 by 0 form is getting formed. So tan x plus x and tan x minus x, correct, upon x square. So can you see, I can write x square and x square over here, so that this will be gone. Tan square x by x square will be gone. Okay. And there will be x raised to power 4. Correct. Now if you want to apply expansion, you can do that, but remember so there are two ways to go about it. First one is write tan x upon x plus x upon x. So this x raised to power 4 will be distributed like one x will be here, another x will be here, tan x minus x upon x cube. So this will become what? 1 plus 1, 2, right? And what about this? So this, remember I told you three important limits formula. So this will become 1 by 3. The value of this limit is 1 by 3. So 2 into 1 by 3 will give you 2 by 3. This is one way of doing it if you remember the limit. Okay, so this limit is 1 by 3. But if you don't remember the limit, so this is anyway becoming 2. Correct. Now what about this? So here we can apply expansion. Remember I told you tan x ka. So tan x ka, it would be x plus x cube by 3. That's it. You have to go up to x cube. And then you are having this. Then you are having minus of x, okay, upon x cube. Can you see this? So this is 2 into 1 by 3. Correct. So one more way. Okay, alpha question. Yes, ProCuber. Alright, so 2 multiply 1 by 3. Easy peasy lemon squeezy. Now one more type of question can you see? Can you just tell me what is the answer of this question? Yes, 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 in the chat box. So again, e raised to power x cube minus 1 minus x cube. So I am going to apply expansion in this. What is the expansion of e raised to power x? 1 plus x square by 2 factorial plus x cube by 3 factorial. है ना? And all the way up to. How can we should notice? क्या पूछ रहे हो? We should expand the series. अच्छा, how to know that we should expand the series? So, Darshan, just tell me one thing. That only like 6-7 expansions you can see. Exponential, logarithmic, sine, cos, right? And that's it. And tan. Okay. So first of all, when you get stuck now, then think कि अच्छा these are. If the problem is not related to e raised to power x, then how will you apply the expansion? Okay. So that's how you do it. Now x will be replaced by x cube, e raised to power x cube is equals to 1 plus x cube whole square by 2 factorial plus x cube whole power cube by 3 factorial. So here x raised to power 6 I will get. So I have to just only think about these three terms. Now put the value. So this will become 1 plus x cube plus x raised to power 6 by 2 factorial is 2, and it will go all the way up to infinity, minus 1 minus x cube upon this is sine raised to power 6 2x, right? So sine 2x raised to power 6 is already there. For this I need something. Okay, so I need 2x raised to power 6 and 2x raised to power 6, so that my this thing will become 1. This is gone. Okay, 1 and x cube is getting cancelled out, so I am left with x raised to power 6. Actually I don't x raised to power 6, ठीक है, upon 2, this is gone already, and this is 2 raised to power 6 x raised to power 6, correct? This is gone, so I am left with 1 upon 2 raised to power 7, that is 1 upon 128. Yes Pranav, absolutely right. Okay, all right, yes. Chalo, one more question now. One student was actually asking, ma'am, especially that Dharshan, no? Ma'am, exactly when you have to apply the expansion. So whenever you see so many things, sin x is already there, cos x is already there, log is already there, okay, together, and the reverse limit is given. Can you see the reverse limit? Reverse question, this is the reverse question. They will give you the question, they will give you the limit value, they will give you the value of the limit, and they will ask you alpha, beta, something like that. Then you have to apply expansion. Okay, let us do it. Apply expansion. Now this is 3 tan square x. So what I am going to do is, I am going to multiply x square and x square. Can I do that? X square and x square. Why I am doing that? So that this tan square x and x square x is 1. So now we are actually having what? 3x square in the denominator. Why am I doing that? Because I want to know till when shall I open my expansion, no? So I will only open my expansion till x square. Once I get x square, I will stop. Okay? Alright, so this is 3 plus alpha. Now sin x. So sin x expansion, remember odd. So x minus x cube by 3 factorial. This is not even required. You just have to write x. Chalo, theek hai. Still, if you want to write x cube tak, we can still go. Now next, plus beta cos x. Remember beta cos x. Expansion of cos x is 1 plus x square by 2 factorial, and actually 1 minus. That's it, that's it. We all have to go up to here only. And then last we are having log 1 minus x. Remember log 1 minus x expansion, all terms negative. So minus x square by 2, that's it. And this is actually coming out as 1 by 3. Limit x tend to 0. Okay, in reverse problems, what you have to do is, you have to now take coefficients of x, constant, alpha, like x square, and so that. Okay, so you have to take the constant terms together, coefficient of x together, coefficient of x square together. Okay, so 3. Constant term, tell me ma'am, 3 is the constant term, and here I cannot find the constant term. Here I can see beta is the constant term, and that's it. So 3 plus beta is the constant term. Okay ma'am. Now terms related to x. Okay, so ma'am, x if you take common, so you will get alpha. Okay, from here you will get beta, and from here you will get minus 1. Okay, no, beta is actually not there, na, terms related to x, only x. So x here, no term of x, here minus 1. And then x square, ma'am, x square, no x square, here you can see minus beta by 2 is the coefficient of x square, and here minus 1 by 2 is the coefficient of x square, and there will be terms, and that would be x cube something coefficient, x raised to power 4 something coefficient, which we are not interested in, upon x raised to power 2 3x square, and this limit value x tend to 0 will give you 1 by 3. Now understand this very very nicely. Okay, understand this very very nicely. Okay, so the value of the limit will be equal to coefficient of x square. So tell me, where is the coefficient of x square? So coefficient of x square, ma'am, this. So you have to separate it out. Separate everything. Just tell me. So limit x tend to 0. Okay. So first thing is constant term 3 plus beta upon 3x square. Correct? Plus limit x tending to 0. This is going to be x alpha minus 1 upon 3x square. Correct? Plus x square upon 3x square and minus beta by 2 minus 1 by 2 plus x cube, there will be something over here upon 3x square, and same goes with x raised to power something else over here upon x square, 3x square. Correct? Now understand this nicely. Tell me that 3x square is in the denominator. The moment you put x equals to 0, you are going to get infinity, right? So this term will become infinity. If this term becomes infinity, what will happen? This limit will not at all exist. That means we have to stop this term from being infinity. Agree or not? Yes, ma'am. So now if you stop this term from being infinity, you have to make the numerator 0. If this is 0, then 0 by infinity will not be a trouble for us. That means 3 plus beta, the very first thing which we can see is 3 plus beta is becoming 0. Beta will give you minus 3. Okay, ma'am, correct. Now again same thing. In here also x and x are getting cancelled out, but also can you see alpha minus 1 upon 3x. The moment you put x equals to 0, this will also become infinity. To protect this from not being infinity, we have to put alpha minus 1 equals to 0. So second thing is alpha minus 1 equals to 0. That will give you alpha equals to 0. Beta minus 3, alpha 0. Done, done, done. Okay. Now this x square is and x square is gone. This will actually give you value of limit. What will be that be? So beta you have already calculated minus 3. If you put minus 3 over here, what will you get? Tell me. So ma'am, minus 3 if I put it over here now. So ma'am, it will be minus of minus 3 by 2 minus 1 by 2 upon 3, ma'am, 3, let's not forget. So this is going to give you, ma'am, this is 3 minus 1 by 2. So 3 minus 1, 2 by 2. So 1 by 3. The moment you put beta minus 1, you are going to get 1 by 3. And 1 by 3 is the value of that limit. That means validated. My alpha and beta are absolutely on point. Alpha and beta you have already got. Alpha is equals to 0, nahi, 1, 1, 1. 1, na, ha. So 2 times 1 minus of minus 3 will give you the final answer, which is 5. Did you understood? This was asked in JEE Main 2024. This year only. Can you see this year they have asked? Okay. Clear? This question is getting clear or not? Tell me. All right. Okay, so using expansion, Pranav is saying explain again. Alpha is 1, yeah. Dharani, no. One more time. Do you want me to explain? One more time. Study with me is also saying, chalo. So many students are saying otherwise. ठीक है, chalo. Let's do it one more time. Okay. This is expansion. This is the thing and 1 by 3. Now tell me. 3 plus alpha sin x. Expansion of sin x. X minus x cube by 3 factorial. Correct? We will go all the way up to only cube. Okay, and then plus beta times cos x, so 1 minus x square by 2 factorial. That's it. Only we have to go up to square, na? Not cube, square. Why? Because if you multiply x square here and x square here, na, so this and this tan square x will be gone. So denominator is x square. So always you open your expansion till the denominator power. Okay, and there is log 1 minus x, so minus x square by 2, clear, upon 3x square, and this limit is 1 by 3. Clear? Okay, now what is the second step? Collect, keep constant terms together, terms related to x together and terms related to x square together. Okay, ma'am. So 3 is the constant term, and here I am not finding constant term. Here beta is the constant term, and here again no constant term. Constant term done. Okay, yes ma'am. All right, now x terms related to x. So one term related to x I can see, if I take x common, you will get alpha. Okay, all right. From here no term of x is getting formed. This is minus 1. Yes, alpha x and minus x. If you take x common, what will you get? Alpha minus 1, yes or no? Okay. Now x square. Where is x square? So x square is outside. Now x square. No x square, no x square. X square minus beta by 2 and x square is minus 1 by 2. Now there will be more terms. Expansion goes all the way up to infinite, right? There will be more terms. There will be term related to x cube. There will be term related to x raised to power 4 and so on. But I will tell you that why we are not bothered about them. Okay? Now just separate it out. 3 plus beta constant term upon 3x square. Limit x tend to 0. Plus, this is x upon 3x square. So this will give you what? 1 by 3x alpha minus 1. Limit x tend to 0. Plus x square gone, 1 by 3 minus 1 by 3 beta plus 1 by 2. Can I do that? And right, so we are separating x square cancelled, and x cube and 3x square. So can you see that x cube upon x square is what? So there will be something x raised to power 4 upon x will be what? There will be something x square and so on. Okay, so there will be 1 by x square term, 1 by x term, constant term. This is 1 by x term, constant term, x term, x square term, x cube term, x raised to power and so on. Yes, got it? Okay, and this value, limiting value is 1 by 3. Now tell me, if the right hand side limit is existing, then only we are saying that limit value is equals to 1 by 3. Just tell me one thing, that this 3 plus beta, if 3 plus beta is any finite quantity, if this is a finite quantity, so finite upon 0 square will give you infinite. If this will become infinite, the whole limit will become non-existent. So we need to actually remove this particular, this is culprit, this is villain, this is villain. This is making my limit equal to infinity. So this is villain, we need to remove it. How will I do that? By making this whole term 0, vanish it. This is gone, making this whole term 0. That means what? Beta plus 3 should be equal to 0. That is the first thing. Understood or not? Yeah, first term denominator is 3x square. Yes, 3. Sorry, 3. Keep it 3. So this is, we need to remove. Again, if I come to this term, again if I put limit x tend to 0, what will it become? Tell me. Ma'am, again finite upon 0 is not defined. So the whole limit will again, it will not be a existent limit. Okay, but in the question they are giving, that's why what we need to do is, this has to be gone again. So this is again another villain found. 2 villain in the same picture. So again, second is alpha minus 1 equals to 0. Correct? Now here there is no term of x. And actually if you notice, this is gone, there is no term. Remove it. This is the constant term which will give you the limit value equal to 1 by 3. Is it giving? Check. Okay, so beta is minus 3. If I put minus 3 over here, just put minus 3 over here. This is your limit value. Final limit value will be given by, actually it will be given by coefficient of x square. So this is your value, coefficient of x square upon this 3. Okay, so this is minus 1 upon 3. If you put beta is equals to minus 3, so this is minus 3 plus 1. So minus 2 by 2. Can you see this is actually coming out as 1 by 3, which is the value of this limit. Okay, so this is fine. This is actually not giving me anything, but it is just verifying, this is actually validating me that yes, 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 you are on a right track. And after that, can you see, again we have actually x cube upon 3x square will give you something x. If you put x tend to 0, so this term will be 0, this term will be automatically 0 because x zeros are in numerator. Now can you tell me that now that you have all the values, just put the value, no? So beta is minus 3, alpha is 1. That's it. So this is 5. Okay, 5 is the correct answer. Yes, 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 tell me. Clear? Okay, now there is one shortcut to get the value of beta. Yes, there is one shortcut from where you can get the value of beta. So you have done incorrect na. Dharani is asking, ma'am, why, what if this would not have came 1 by 3? That means you have done some error. Okay, that means there is some error in your solution. Now there is one easy method to get the value of beta. Shall I tell you? Yes, shall I tell you? Okay, but anyway, because we need alpha also, so we have to solve it out. But if in any question you never know in JEE Main, only the value of one variable is asked, na, then you can I will apply this ninja technique. Okay, so what you will do is, I always say, whenever you see limit question, what do? Always check form. Check form for me. Okay, ma'am, if you check form, na, so the denominator will be 3 tan square x, right? So 3 into 0, 0. Yes, ma'am. What about numerator? You put 0. So, ma'am, 3 plus sine 0 will be 0. So 3 plus, ma'am, 0. Then beta cos 0. Cos 0 is 1. Plus beta. Okay. And plus again, if you put x equals to 0, log 1 is always 0. Can you see the form is becoming beta plus 3 by 0? The form is becoming beta plus 3 by 0. Now tell me, if beta plus 3, you have two options. Beta plus 3 should be 0 or non-zero. Suppose beta plus 3 is non-zero, finite quantity, for example, beta plus 3 becomes 1 or 2 or 3 or 4. Okay, then what will happen, tell me? So ma'am, it will become 1 by 0 or something by 0. Something by 0 will become not defined. So this limit will become infinite. But in the question, they are saying that limit is 1 by 3. It should be 1 by 3. It should exist and it should be 1 by 3. So it should not be infinite limit. So if you want to make, remember, the very in the beginning we did that, the same similar type of question we did. Similar type of question we did, right? So this should be 0 by 0. For that, beta plus 3 should be 0. Remember or not, shall I take you to that particular problem wherein they were asking, in the beginning we did, okay? So this was the question, yeah. We were calculating form of this limit and they were saying limit exists. So I was saying if limit is existing, that numerator should also be 0 so that we get a proper indeterminate form. So 15 minus a should be 0, then only we will get the answer. Okay. Done. Okay, now using substitution. ठीक है, तो now check. Let's check it out. Limit x tend to pi by 2. The moment you put pi by 2, what will you get? Let's check the form. Pi by 2, ma'am, cos pi by 2 is what? 0. So 2 raised to power 0 is 1 minus 1. Pi by 2 if you put 0. So ma'am, 0 by 0 form, proper. But sometimes now you don't know how to like tackle this problem. Okay, I mean, what will you apply it over here? Okay. So now what will you do? You will use substitution over here. How do you do that? So put x equals to pi by 2 plus h, or minus h also you can use. If x equals to pi by 2 plus h, because anyway we are going to use what? X equals to pi by 2 plus h. So you put it and h tend to 0. So now the limit will get converted into limit h tend to 0 and 2 raised to power minus cos of 90 plus h, or pi by 2 plus h also you can write, minus 1 upon then x will get replaced by what? Pi by 2 plus h, and x minus pi by 2 will become h. Okay, so this will become, now cos 90 plus theta is minus sin theta, 1 minus sign is already there. So 2 raised to power sin h minus 1 upon, that is pi by 2 plus h and 1 more h, limit h tend to 0. Now do you remember that standard limit? 2 raised to power 0 minus 1 upon same 0 will give you log 2. Yes? So this is actually, so yes, you need sin h. So what you need to do is you need sin h over here and here. So that 2 raised to power sin h minus 1, this will become log of 2. Sin h by h is again gone because it is 1. Now you put h equals to 0, it will become pi by 2. So 2 by pi, can you see how beautifully, how smooth this limit became? How smooth this limit became? Yes or no? Just you put x equals to pi by 2 plus h, automatically everything will fall in place. Okay? Alright. Now there was this question which was asked in JEE Main 2017. Again, you can use substitution over here. Alright, so let's use substitution. Cot x minus cos x upon pi minus 2x whole cube. So what I'm going to do is, again, x equals to pi by 2 plus h. Can I do that? Okay. So h will become 0. So now limit will be changed to limit h tend to 0. Cot of pi by 2 plus h minus cos of pi by 2 plus h whole upon pi minus 2x. So pi minus 2 pi by 2 plus h whole cube. Or rather, actually, don't take pi by 2 plus h in here. Okay, I will suggest take pi by 2 minus h. Although this will also give you answer, but pi by 2 plus h has a problem. You know what? Pi by 2 minus h, every ratio is positive in first quadrant. So cot pi by 2 minus h is tan. So you don't have to think about the sign first quadrant, second quadrant, right? So this is minus. Let's keep it like this. Cot 90 minus theta is tan h. Minus this is sin h. Upon, now this. Pi minus 2 to cancel, one more pi. Okay, and then minus minus plus. So 2h cube, so 8h cube. Correct? Okay. Now what you can do is take sine common. This tan h ko you can write sine by cos. Take sin h common. So it will become 1 by cos h minus 1 upon 8h cube. So 1h is gone, now 8h square. Now you take the LCM. So sin h and h is gone, so this is 1 minus cos h upon, this is sin h is gone, so cos h is already there, 8h square. This is already 1 by 2, so the final answer is 1 by 16. Remember the standard limit, 1 minus cos 0 upon 0 square. Remember that. So 1 by 16, option B is absolutely right. Yes, monster? Clear? Yes, Vijayashri, if b plus 3 is 0, then it is indeterminate form. Yes, yes, yes. Yes, Pranav, absolutely right. Okay, now Can you see? Till now we have only done 0 by 0 form. Only 0 by 0 form. So in limit, since like more than 3 hours, what we are doing is only 0 by 0 form. But now your task will be very easy. Now we have 6 more forms to be left out. And 6 forms we are going to do in less than an hour. Are you kidding me? 6 forms, rest 6 forms will be less than 1 hour. Okay, so maximum time was given to 0 by 0. Okay, and this infinity by infinity. Now whenever you see infinity by infinity, now the drill to solve infinity by infinity form is take the maximum power of x common. Take the highest thing common. So here in both, can you see now the form is infinity by infinity? So what you can do is, again, of course you can apply L'Hopital in this, but if L'Hopital is not applicable, then what will you do? That's why. So take x common from numerator and denominator. It will be 1 upon 1 by x, 1 upon 2 by x. X ko the moment you put infinity, it will become 0, it will become 0. So final answer will be 1 by 1. Easy? Yes, again L'Hopital will be applicable. One more question in front of you. Now you have to take x square common from numerator and denominator. Now x square, the moment you take common, 1 minus 4 upon 3. Right? The moment, sorry, 4 upon x, क्या लिख रही हूँ? 3. 4 upon x plus 5 upon x square upon, now if you take x square common, 3 minus, oh my god. Acha, previous question Meena is asking how denominator cos h vanished. No, it is not vanished. The moment you put 0, na, cos 0 will become 1. So in the end you put cos 0, 1. Okay? No. What is the highest power? Tell me. This is wrong. So we have to take x cube common. Because we could not see that, na? X cube should be taken common. So x cube will be taken common from numerator and denominator both. So this will be 1 by x minus 4 by x square plus 5 by x cube. Correct? Upon. This is 3 by x minus 1 plus 2 by x cube. Now tell me, this is 0, 0, 0. So numerator is complete. This is cancelled out. So numerator is completely 0 and denominator is minus 1. So final answer is 0. Yes. Okay. Infinity by infinity. Some more questions. Now this question. X tend to minus infinity. You have to be very careful when talking about minus infinity. So now what you can do is safe side. I will tell you, if you don't want to mess it up, just put x equals to minus t. It would be great if you put x equals to minus t. The moment you put x equals to minus t, now the question will be limit x tend to t tend to infinity. That's it. 3t square plus 2, it will not get affected, but this is minus t minus 2. Now you solve it out however you want to do. What you need to do is take t common. Highest power is t, not t square, because root t square is t. Take t common. T if I take common from numerator and denominator, so root is there. If you take t square common, it will become t outside. So 3 plus 2 by t square upon, if you take t common, minus 1 minus 2 by t. Cancel. Now you put t is equals to what? Plus infinity. Right? T will become plus infinity. So this is 0. This is also 0. Tell me, root 3 upon minus 1. Root 3 will be the, minus root 3 will be the correct answer. Be careful. Monster is saying, why need to take common x square if we can take common x? So the drill is in infinity by infinity form. You have to take highest power common. Why, Monster? Because you have to take infinity common. You have to remove infinity from the bracket, because infinity is something which is bothering you. Okay, so maximum infinity you take common and then you are done. And now if you do not do this step, then some students will give you root 3 answer. That is wrong. This is a googly question. Now again, x is the highest power. Take it common. x, if I remove x from numerator and denominator, 1 upon sin x upon x, 1 minus cos square x upon x. Now x is infinity. Sin infinity by infinity will become 0 because finite by infinity is 0. Again finite by infinity is 0. So root 1 will give you 1 as the correct answer. Yes? Alright. Now again another question. You have to take maximum infinity common. 3 raised to power n, 4 raised to power n, 2 raised to power n, 5 raised to power n. Which is maximum one? 5 raised to power n. So you have to take 5 raised to power n common. Take 5 raised to power n common from numerator and denominator. So this is going to be 3 by 5 raised to power n, 4 by 5 raised to power n, 2 by 5 raised to power n, 1. Limit n tend to infinity. Right, this is gone. Now tell me 3 by 5 raised to power infinity is what? 0. So this is gone, 0. 4 by fraction raised to power infinity, 0. Fraction raised to power infinity. So the answer is 0 minus 0 upon 0 minus 1. So 0 upon minus 1 will give you 0 as the final answer. Okay? Now what about this? This is actually sine of 2 raised to power x upon 2 raised to power x. Tell me. Tell me the answer of this last part. So now again, this is a finite quantity. The moment you put x equals to infinity, 2 raised to power infinity, the finite upon infinity will become 0. Okay? Alright. Clear? Now there is this, I would say, yeah. So there is this shortcut, ninja shortcut, I would say. Okay. So how will you apply this shortcut? Okay. So can you see that degree of numerator and denominator are equal? Okay. Degree of numerator is equal to degree of denominator. Degree of numerator and denominator are equal. Then what will happen? The shortcut is just write the highest power coefficient upon highest power coefficient 1 upon 5. That's it. You are done. Alright. Now this. In here, can you see degree of numerator is less than degree of denominator? Okay. So in this case, what will happen? Can you see the infinity of denominator is bigger? When infinity of denominator is bigger, it will become 0. So this is your 0. Right? What about this? Now this time, infinity of numerator is greater. So denominator is less than numerator. So degree of numerator is greater. Then it will become infinity. What about this? Power 4 and 3. So this will become actually minus infinity. Did you understand the shortcut? Did you understand the shortcut? Yes or no? Tell me. Okay. It is very simple. When both are equal, highest power coefficient upon highest power coefficient, this is done. When the numerator degree is lesser, then the answer will be 0. The denominator degree is greater, then answer will be infinity or minus infinity depending upon the coefficients. Yes, this is important for JEE. Everything we are studying, that is important for JEE only. No, this trick board, not in boards. Okay, now one more question I will give you. This question. Can anybody tell me the answer of this question? Let's not forget this. -2, some of you are saying let's see, because x tend to minus infinity is there, so we have to be very careful. Okay, so if x is tending towards minus infinity now, so if we take x cube common, then we will think x cube, if I take common, okay, by normal method, let me check. So if I take x cube common, what will happen, tell me? X cube common, so 2 ma'am, plus 1 by x square plus 1 by x cube taken common, and from here if you take x cube taken common, so you will be getting -1 minus x cube is gone, right, minus 1 by x square plus 1 by x cube, right, this is gone, this is gone, this is gone, this is gone. -2 is the correct answer. Yes, clear? Give me a big thumbs up if you have understood this. -2, absolutely right. Okay, but safe side, what you need to do is put x equals to -t, then calculate. Okay, if there is minus infinity, na, put x equals to -t, then calculate. Okay, all right. Thank you, Kritika. Thank you so much. Now, so done. Second form also done. 0 by 0 done. Infinity by infinity done. Now next, infinity minus infinity form. Okay, so infinity minus infinity form, there are multiple ways of doing that. There are multiple ways of handling it. The very first method is put x equals to 1 by y or 1 by t. If you do that, the whole question is x tend to 0, because here you can't do anything. So this is limit x tend to infinity, y tend to 0 plus. Remember, when x is infinity, so y is 0 plus. And this is square root of 1 by y square minus 8 upon y and minus 1 by y. Okay. Now, if you take LCM, what will you get? So, this is 1 minus 8y ka root, and this will be what? Root y square minus 1 by y. Correct? That would be modulus y. Now, modulus y will get opened with y only, because y is what? So, this is modulus y, which will get opened with positive y. Y over here, if you see, is nothing but 0 positive. So, that's why no need to panic. Let's write y over here. Limit y tend to 0 plus. Now tell me, what kind of form are you able to see? 1 minus 8y minus 1 upon y. This is a normal. Do you think this is normal 0 by 0 form? I told you every form will get converted into 0 by 0 form. Now this is normal 0 by 0 form. Rationalize it. So the moment you rationalize, what will you get is 1 minus 8y plus 1 upon 1 minus 8y plus 1. Correct? So this is going to be what? 1 minus 8y minus 1, and this is y square root 1 minus 8y plus 1. 1 and 1 cancel, y and y cancel, so this is minus 8 upon, now you put 0, y is equals to 0. 1 plus 1, so root 2 into root 2 by root 2. So this will give you minus of 4 root 2 as the final answer. Yes? Okay. What did we do? We just changed this 1 by y, and the moment you do solve it out, finally get the y expression, you will get 0 by 0 form, which we have done so many times. Okay. All right. So x square minus 8x minus 8. Now I have another method for this also. One more method, very important method, okay? So remember, I was telling you binomial expansion, so 1 plus x raised to power n, right? is equals to 1 plus nx plus n minus 1 n minus 1 by 2 factorial x square and so on. This is applicable when this thing is very small. This is applicable when 1 plus x is very small. Okay, so here if I write x square minus 8x power half, can I do that? Minus x, limit x tend to infinity. Now listen to this carefully, because the steps involved are very less, but the logic here is a little bit on a difficult side. Okay, now what I'm going to do is, because I want to apply binomial expansion, I want 1 over here. Instead of x square I want 1. So can I take x square common? If I take x square common from here, now the power is half, it will become x. So x will be here, x square if I take common, x is done. 1 minus 8 by x, and this is half, minus x. Yes or no? Okay, now here can I apply binomial expansion? Let me check. X is here 1 minus 8 by x power half. So 1 is here, and this very quantity 8 by x should be very less. 8 by infinity, yes ma'am, it is very less, so you can apply. And also let me tell you that majority of the time what we do is 1 plus x raised to power n can be approximated to 1 plus nx. This n will come in front, that's it. So this half will come in front, very easy. 1 minus 1 by 2 will come in front, and 8 by x minus x. X is already outside. Okay, alright. Now multiply x again. After applying binomial expansion, you have to multiply x again. So x minus, this is 4 by x. So this is 4. You are multiplying x. X multiply x, 1. X multiply this, x cancel, so x minus 4. Correct? And minus x is already there. So this is actually going to become what? Minus 4 is the answer, minus 4. But we were getting minus 4 root 2. Now let me check. Root 2 I was getting from somewhere else. Did I do anything wrong? Actually it was not root 2. If you put y is equals to 0, 1 plus 1, this is 2. So minus 8 by 2, yes. That's it. Minus 8 by 2 is absolutely right now. So minus 4 from here. Minus 4 from here, and minus 4 from here also. Minus 4. Okay. Alright. Now one more similar type of question. If you put x equals to 1, this will become infinity. Infinity minus infinity form basically. So you have to solve it out. So 1 minus x square, x minus 1. So take LCM. 1 minus x square. Or rather you do one thing, first of all solve it. So 2 upon 1 minus x square, this is minus 1 upon 1 minus x. Can I write it this way? Now take LCM, because the sign should match. So this is actually 1 minus x, 1 plus x. 1 minus x square is the LCM, 2 minus 1 plus x. So this is 1 minus x upon 1 minus x square. So overall only 1 upon 1 plus x is left out. Now you put x equals to 1, 1 by 2 is the correct answer. Yes? Yes, Pranav, absolutely right. Okay. Now there is one question which was asked in JEE Main 2021. So if you have understood my binomial approximation method now, then you are going to kill this question. Okay. Chalo, you do it. Similar question, you have to apply binomial approximation. Can you see a similar type of question? You have to apply the same method. Copy paste this method, apply it over here, tell me the answer of this question. Let's see how many of you are able to do it. Chalo, let's do it. Same method, same approach. Okay, ma'am. So this is x square minus x plus 1 raised to power half. Correct? Minus ax is already there, and this value, limit of this expression is becoming b. Okay? Alright. Now what you need to do is, applying binomial expansion, take x square common. The moment you take x square common, it will become x. Because x square, if you take common, x square ki power half will become x. And this is going to be 1 minus 1 by x plus 1 by x square. Minus ax. Limit x tend to infinity. Now you have to apply binomial expansion. है ना? तो 1 plus something raised to power n is equals to 1 plus n something. Here that something is this whole value. So I'll multiply half over here. So this will become x, half will be, so 1 minus 1 by 2x plus 1 by 2x square minus ax, bracket close, minus ax. Now you have to multiply x inside. Okay, ma'am, as you say. If you multiply x inside, what will you get is x, okay, minus x, x cancel the 1 by 2 plus 1 by 2x, because 1x is getting cancelled and this is minus ax. Now club the terms together, x will be together. So 1 minus a times x minus 1 by 2 plus 1 by 2x, that's it. Yes or no? And this whole value should be equal to b. Correct? Now x is tending towards infinity. Please keep that in mind. If x is infinity, this is 0. This is a constant term, no harm. And this term, 1 minus ax, now observe this term. This term is making the whole limit infinity. Why? Because the moment you put x equals to infinity, this whole term becomes infinity, then limit value will become infinity, which is not possible. So this has to go. Again, villain ki entry ho gayi, so we have to remove this villain, make it 0. So 1 minus a should be equals to 0. A is equals to 1. So clearly A is 1. Option D and C are gone because A is equals to 1. And now the final value of this limit is clearly minus half. So B is minus half, option B minus half. Okay, so this is your B. Done. Pranav, absolutely right. Absolutely correct. Okay, so now you have done 3 forms successfully done. Which one? 0 by 0 done. So many like methods we have done for 0 by 0, standard limits, everything we have done. Infinity by infinity, ma'am, done. Then infinity minus infinity is also done. Now 3 forms done, 4 more remaining. You will see that quickly we are going to do that one by one, tuck. Okay, now next form is 0 multiply infinity form. Okay, 0 multiply infinity. So I always identify the form, then understand that what to do. Remember I told you crime patrol. So whenever crime happens, what does police do? Does police automatically file FIR, then they go to find anyone kya? No. They ask everything. They will ask you, you have a boyfriend? No boyfriend. Girlfriend? No girlfriend. Mother, father. Spouse, husband, wife, bacche, everything they will ask. Then they will stand up ki, now I will take some action. So you also do the same thing, na? First of all, find out the form. Then think, acha, okay. If it is 0 by infinity, then you will apply that method. Now infinity. So this is infinity and this is sine 1 by infinity 0. So for 0 multiply infinity, now try to convert either in 0 by 0 or infinity by infinity. Yes, you have to do something so that that thing becomes 0 by 0 or infinity by infinity. So this is sine 1 by x. Now what I'm going to do is this x I will keep it over here. Can I do that? Now tell me what is the form. Just by doing simple manipulation, can you see the form has been changed now? Sine of 1 by infinity, which is 0. So sine 0. And this is 1 by infinity. So this is sine 0. Don't you think this is the same thing, sine 0 by sine 0? So this value is actually coming out as 1. Easy peasy. Okay. Alright. Yes. Now over here, pi by 4, which form is this? So the moment you put pi by 4, this is 0 and this is sec pi by 2 infinity. So 1 minus tan x, now change the form, upon cos 2x. Now can you see 0 by 0 form is getting formed, na? This is again back to 0 by 0. So you have converted the form and now you apply the normal methods, okay? So now 1 minus tan x. So cos 2x is 1 minus tan square x and 1 plus tan square x. Now you can split this out. So this will become 1 upon 1 plus tan x and 1 plus tan square x. Limit extend to pi by 4. The moment you put pi by 4 over here, what will you get is 1 plus 1 upon 1 plus 1. So the answer is nothing but 1. Oh, nice. You guys are already getting 1. Both the answers are 1 only. Okay. Alright. Now another question on your screen. Okay, one more question on your screen. Let us see how many of you are able to think about this question. Okay, so now let's take 5 minutes break, okay? Let's take 5 minutes break and let's take 10 minutes break, then we will resume. Now we only have to do like till before 10:30 we'll be done by this session, okay? And you also try this question. Let's take 10 minutes break. Let's meet at 10:10. Okay? I'm feeling a little thirsty. I think I should take a break. Out of breath I am going. Okay? So let me not torture myself just by saying, sometimes we do that, na? 5 minutes or 5 minutes or 5 minutes or. So let me just come back after refreshing myself. So 10 minutes you also take. Go whatever you want to do. Just don't scroll. Okay? Chalo, bye. See you. hello, hello, hello. Hello, 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 hello. Okay, all right, yes. So we need to figure out the limit of this expression. I can already see that so many of you have said 120, but there is an easy approach of this. So why not just convert GIF into fractional part? Do you know this formula? How many of you know this formula? Let me know. X plus x equals to GIF x plus fractional part of x. So I am going to write GIF x equals to x minus fractional part of x. So x is outside. GIF 1 by x is nothing but 1 by x minus fractional part of 1 by x. Yes or no? Plus, this is 2 by x minus fractional part of 2 by x, and all the way up to last term will be what? Tell me. 15 by x minus fractional part of 15 by x. Okay. And bracket close. Alright, now x is here and 1 by x, 2 by x, 15 by x. So 1 plus 2 plus 3 and all the way up to 15 is there upon x. Correct? So what I am doing is I am keeping these terms together and I am keeping the fractional part of x terms together. So can I do that? So x multiply, so minus of x. Now this is 1 by x fractional part, 2 by x fractional part, 3 by x fractional part, and all the way up to 15 by x fractional part. Okay, all right. Now x you can cancel it out. 1 to 15 if you add, what will you get? 15 into 16 by 2 minus. This is your 0 multiply all the fractional parts which are finite number. So 0 multiply finite will become 0. So this is 8. 15 multiply 8. Only 120 will be the answer because this part is 0 multiply fractional part which is 0. Yes, study with me. Got it? Good question, I would say. Yes. All right. Okay, now we are actually done with which form? 0 multiply infinity form is also done. 5 forms done. Okay, sorry, 4 forms done. Now 3 more left. Out of 3, this is again very important form, that is 1 raised to power infinity form. Okay. So 1 raised to power infinity form is very easy, not at all difficult, right? But you have to understand the trick behind it. First of all, you have to identify the form. So fx raised to power gx, here fx is tending towards 1 and gx is tending towards infinity. So whenever you spot 1 raised to power infinity form, what will you do? Tell me. So 1 raised to power infinity, whenever you see, na, so 1 raised to power infinity, this is your gx. What you will do is, this will be equals to e raised to power this power. Now e raised to power this infinity, what is infinity? Gx. So gx will come in front and you have to subtract 1 from this base which is fx. So fx minus 1. Do you remember this formula? Very easy formula. E raised to power, that power will come over here. That power will come over here, gx. So e raised to power gx. And this fx will be subtracted by 1. Okay. Let me just give you some example of it, right? So this is the very first result, not the question. This is result. You have to remember this result, okay? So this is again the moment you put 0, what is this form? Tell me. Ma'am, 1 raised to power infinity form. Okay, how do you tackle it? E raised to power, now this power will be 1 by x. Okay, now 1 plus x minus 1. 1 plus x minus 1. 1, 1 cancel, x cancel. This will become e raised to power 1. That's it. Done. The answer is what? E raised to power 1. Now again similar thing, the moment you put infinity, 1 plus 1 by infinity, this is 0, 1 plus 0, so 1 raised to power infinity form. How will you tackle it? E raised to power x, this power will come in front and you have to subtract 1 from the base. That's it. Okay, limit is same, x tend to infinity. 1 gone, x by x gone, e raised to power 1 again. So these two results that you have to remember. Okay, these are the two results that you have to remember. Have a look. Yes, clear? Yes, Shrinu, absolutely right. Okay, on point. Chalo. Now, 2 more questions you can see on your screen. Again, 1 raised to power infinity form. Solve it with me. 1 plus 0 raised to power cosec 0 is what? Infinity, right? So again, e raised to power, this power will be cosec x. And now, base 1 plus x minus 1. Correct? 1 and 1 cancel out. So it will become what? E raised to power x into cosec x. Cosec x will be 1 upon sin x. And please remember, I am not doing it, but limit is already there. So limit x tend to 0 is already there. Limit x tend to 0 is already there. So e raised to power 1 again. Again e. Now tell me the answer of this question. Let's see how many of you are able to do it. Answer of this question. This will give you what? 2 by x. So again, if you put x equals to 0, what will you get? 1 plus 1 plus 1, 3. 3 upon 3 will give you 1. 1 raised to power 2 by 0, so 1 raised to power infinity. Okay, alright. Now, so it is going to give you e raised to power. This power 2 by x will be here. And now you have to subtract 1 from the base. A raised to power x plus b raised to power x plus c raised to power x upon 3 minus 1. Limit x tend to 0. Okay. Alright. Now, e raised to power 2 upon x is already there. If I take LCM, this will become minus 3, right? So, a raised to power x minus 1 plus b raised to power x minus 1 plus c raised to power x minus 1. So, minus 3 instead of writing minus 3, I wrote minus 1, minus 1, minus 1, and this x I am going to distribute it over here. Overall x, then separate it out. And also if you take an LCM, so here 3 will be there. Yes or no? ABC is the answer. One student is saying no, ABC is not the answer. Okay. ABC something is the answer. Okay. 2 by 3 is already there, right? Clear? Now what is this log A, log B, log C? Remember that standard limits. E raised to power 2 upon 3, log of A, log of B, log of C. Right? And this is going to be e raised to power 2 by 3 log of a, b, c using the property of logarithm. Log m plus log n is log m into n, and this power 2 by 3 will go over here. So, e raised to power log a, b, c raised to power 2 by 3 by using fundamental identity. E and log will anti each other, cancel each other. So, the final answer will be a, b, c raised to power 2 by 3. No, power 2 by 3. 2 by 3. Yes, Shrenu, absolutely right. Now you are correct. Okay. Alright, clear. 1 raised to power infinity, getting clear? Alright. Now one more question. Over here, let's see how many of you do this question. Now I'm gonna wait. Now it's on you. Okay, so again infinity raised 1 raised to power infinity form getting created. Kya? If you put 0, this is 2 by 2. So 1 raised to power infinity, again e raised to power limit of x tend to 0. This is, now power will be 1 by x square, and you have to subtract 1 from the base. Is there any problem in writing the direct this statement, this thing? Any problem in writing this? C, Krishna is saying C. Let's see. Now take LCM. So e raised to power limit x tend to 0, 1 by x square, 3x square plus 2 minus 7x square minus 2 upon 7x square plus 2. 2 cancel. 3x square minus 7x square is 4x square. E raised to power limit x tend to 0, 1 by x square minus 4x square upon 7x square plus 2. x square cancel, and the moment you put x equals to 0, you are going to get e raised to power minus 4 upon 2, e raised to power minus 2, okay, 1 upon e square is the correct answer, which is option A, 1 upon e square. Yes, Shrinu, absolutely right. Krishna, wrong. C is not right. Study with me, also wrong. Tom, you are correct. A answer absolutely right. Okay, got it, because minus 4 sign is there. Maybe you forgot minus 4 sign. Okay, all right. Now another very good question from JEE Main 2021, and a similar type of question is observed in JEE Main 2024 April attempt. Similar type of question. Okay, let's do these questions. All right. Now this is 2021 question. So two limits are given to us, alpha and beta, and we are here to figure out what roots of this equation. Alpha and beta are roots of the equation. Okay, so alpha and beta is something which we need to figure out, and then everything will be sorted. Are we ready for it? Okay, so first of all, alpha is pi by 4, so always check form of the limit. The moment you put pi by 4, numerator is tan 1 minus tan pi by 4 minus, so tan pi by 4 is 1, 1 minus 1, 0, and this is cos pi by 2, 0, 0 by 0 form. Okay, all right, so what we will do is tan cube minus tan x. So can I take tan x out? Tan square x minus 1. What about this? Cos x plus pi by 4. So 1 by root 2 cos x minus sin x. Yes or no? Let's open this. Cos x plus pi by 4. Cos a cos b minus sin a sin b. So cos a cos b, cos x cos pi by 4, 1 by root 2 already taken common, like this. Okay, alpha will be equals to root 2 and x equals to pi by 4, right? Root 2 limit x tend to pi by 4, so we know that this is gone. Tan pi by 4 is going to be 1, so if we can keep it 1 over here. Tan square x minus 1, if I just convert this into sine and cos, what will I get? So I'm gonna get sine square x minus cos square x upon cos square x, and we are having cos x minus sin x also. Correct? If I split this, what will I get? So this is root 2. Okay, this is cos square x. The moment you put pi by 4 over here, cos pi by 4 square is, so this is going to be 1 by 2. Sine square minus cos square will give you sin x plus cos x, and sin x minus cos x, and this is cos x minus sin x. So we can cancel them out, but with a negative sign we need to take common. So actually minus 2 root 2 is something which we are getting. Yes, minus 2 root 2. Minus 2 root 2. Okay, sorry. This is again 1 by root 2 plus 1 by root 2. This is also left out now, so 1 by root 2. So final answer is minus root 2 upon 1 by 2, and this is 1 by root 2 plus 1 by root 2. So root 2 is getting cancelled out, 1 plus 1, 2, so this is going to be minus 4. Alpha is actually coming out as minus 4. Okay. Krishna, sequence and series already done. Last lecture was sequence and series. Go and watch it. ठीक है, चलो, beta is this. Now, which form is this? Who is going to tell me? Which form is this? The moment you put x tend to 0, so cos 0 is 1 raised to power infinity. Cot 0 is what? Infinity, right? 1 raised to power infinity form. How do you handle this form? Beta. E raised to power cot of x cos x minus 1. Right? This is your form. Now cos x minus 1, remember that standard limit? 1 minus cos x upon x square. So for this I want x square, and this is cot x, so cot x can be written down as e raised to power, so minus, if I take common, 1 minus cos x, this is my tan x, correct? 1 minus cos x ko I need x square, so that I can write half over here, and if I am dividing x square I need to multiply also. Tan x by x is gone, so the answer will be e raised to power minus half into 0, because 1x will be left out. So e raised to power 0 will be the answer. Beta is 1. So beta is coming out as 1. Alpha minus 4, beta 1. Yes. So alpha 4 minus 4, beta 1. Now form a quadratic equations whose roots are this. So x square minus of sum of roots is minus 3x. Product of roots is minus 4 equals to 0. X square plus 3x minus 4 equals to 0. Compare 1, 3. Any option having 1, 3, option D is absolutely matching. Okay, so a similar type of question was observed in JEE Main 2024. So they have actually changed the limits, but the style was exactly same. Are we ready for that? Shall I give you homework or shall we do it now? Tell me this question. Do you want to do it now or shall I give you as homework? Homework or now? Let's vote. 2024 question. Right now you want to do or you want to take it as homework? Pranav is saying homework. Okay. What about others? Homework? Study with me also homework. Chalo, I'll give you a hint. Remember I told you? Acha, you tell me. If you are able to tell me, then I'll give you homework. This particular thing, when two exponents are observed in subtraction sign, what do we do? Today I told you. Today in the evening. Whenever you see two exponents together, what do you do? In the chat box. What is the trick? Okay. Let me just go back. Take the second exponent common. Yes, that was the trick. Exact similar question we have done it. Okay, whenever you see two exponents together, what do you do? Take the second exponent common. Right? Let me just go back and take the second exponent common. Where was that? Yes. Whenever you see two exponents, trick is take second exponent common. Exactly same question. Exactly same question was asked in JEE Main 2024. So do you see, class notes are very important. You never know which part of class notes will be there in JEE Main 2024. Okay. So yes. So this will be solved. Just one step, you will be done exactly same, and this is also not very difficult. And yes, one more important thing, that while writing now you will get the roots alpha and beta. Now in here you have to compare. You don't have to equate. No need to equate. You have to compare. Okay. Alright. So this is a homework question given. Now last two forms of limits. So there were 7 forms, 5 done nicely. Now 2 forms, 0 raised to power 0 and infinity raised to power 0. So whenever you see 0 raised to power 0 form, what will you do? Or infinity raised to power infinity, there is one trick. Take logarithm. Okay. So what you need to do is take logarithm on both sides. To take logarithm, log of L is equals to what? Log of x raised to power x, limit x raised 10 to 0 plus. Did you notice what this form is? 0 raised to power 0 form is there. Okay. So 0 raised to power 0 form means in both the forms take logarithm. Something raised to power something, remember, you have to take logarithm. Now log of L, this x will come in front. So limit x 10 to 0 plus this x will come in front, log of x. So this is going to be what? Now the form has been changed. The form has been changed. Okay. Now if you check the form is not at all 0 raised to power 0. The form is 0 multiply log of 0. Log of 0 is infinity. Yes. Log of 0 is minus infinity. So this is 0 multiply. Now the form is changed. 0 multiply infinity form. Now 0 multiply infinity, how do you take care of that? By converting it into 0 by 0 or infinity by infinity form. So this is log x upon 1 by x limit. Now tell me, can you see we have changed the form? 0 by 0 changed to 0 multiply infinity, changed to infinity by infinity. Now you put 0. Log 0 is infinity and 1 by 0 is infinity, infinity by infinity. And now you just apply L'Hopital. L'Hopital. Yes. So 1 upon x and this is minus 1 upon x square. So this is minus of x. This is going to give you a big fat 0. Alright. Yes. Done. Done. Now. So minus x. So log L. What is the value of limit? Log L is 0. The value of limit is not 0. Please understand, this is very important, because now last step should be take anti-log also, because in the beginning L was the value of limit, you took log. So the value of limit is what? 1. The value of limit L is 1. Clear? Perfect. Another similar question, hai na? Do not forget the last step. Another similar question, let's see how many of you are able to do it. Again, something raised to power something, 0 by 0 form spotted. What will you do? L is equals to sin x raised to power x. Limit x tend to 0 plus. Take log. Ln L is equals to x log of sin x. Applying property also. Limit x tend to 0 plus. Okay. Ln L is what? X log sin x. Okay. So now x log sin x, so log sin x is here and this is 1 by x. Now see infinity by infinity form again. L'Hopital. 1 upon cos x. Derivative of sin x one more time you have to do. So that is minus sin x. Sorry, 1 by, sorry. What am I doing? No. So differentiate, L'Hopital we are applying, right? So log sin x derivative is 1 by sin x and sin x derivative is cos x. Correct? Upon 1 by x is minus 1 by x square. So this is actually minus x square upon tan x, which will give you x minus x or x by tan x. Correct? So this value is also 0. That means log L is again 0, L equals to 1. So this limit is also 1. Right? Okay. This limit is also 1. All right. Clear. Okay. So here we are done. So now we are done with the, ma'am basic से नहीं कराओगे क्या? Basic से ही हम 6 बजे से we are doing basics only, है ना? So now we are done with today's session. Now if you come by the end of the session and if you look for the basics, by when we are finishing limits, then you won't be able to. Theory be already discussed. Each and every part of theory is already discussed, hai na? So we are done with today's session, and also some of you were asking about JEE Main PYQs. So I will highly recommend the Tattva books. Yes, Tattva books will have all the recent year questions, so please refer to it. Link is already given in the description box if you are looking for any PYQ books. Okay, all right. So now I'll be seeing you on Saturday. Yes, with which chapter? Acha, you tell me which chapter you want to see next in the road series. Write down in the comment section. Okay, ProCuber, we make it till the end. क्या बात है? So limits was also not a very difficult chapter. It is fun chapter also, and it is not heavy chapter, not at all a heavy chapter. Okay, so I will recommend you to practice 20 2020, 2021, 2022, 2023, 2024. 5-year, past 5-year PYQs you do from this chapter and you will be pro in limits, okay? So once the stream is done, please tell me that which chapter you want to see next in the road series. This is me, Namrata, signing off.